journals. Sir was awarded with the Emerald Highly Commended Paper Award 2018 for the research paper titled A Framework for Untapped Creativity, Leveraging Components of Individual Creativity for Organizational Innovation. To his credit, Sir also has a first prize on All India level in National Conference on Research Paper Presentation, AIMACME New Delhi 2007. Sir is a gold medalist in MMS program 1998. Sir has been supervising many PhD research scholars and students which are pursuing MBA for their final dissertations and summer training reports. Apart from this, Sir has been holding in the past different key positions at NIT Kurukshetra. Sir has impeccable research skill and has conducted more than 350 workshops on topics like MS Excel, SPSS, MOS, Smart PLS, RStudio, to name a few. He has been a reviewer in various esteemed journals and is the visiting faculty at IIM Rohtak, IIM Lucknow for sessions from September-December 2010, October-December 2011, and September-December 2012. Sir is a regular guest faculty in Academic Staff College, BPS Uni Kanpur, Academic Staff College, GJU Hisar, Academic Staff College Kurukshetra, University Kurukshetra, to name a few. Sir also has cyber presence through his YouTube channel, which I would like to add is a very popular channel nowadays among the researchers and data analysis training Google group. We are really thankful to you, sir, for agreeing to be the resource person for the sessions today. And really, we look forward to a very happy and constructive learning from your side, sir. Thank you so much, sir, for being there for us. Thank you, sir. Over to you.
Thank you, ma'am. So let's start with the day number 2. And this is the schedule. Hope you are able to see my screen. So we will go through a review of a bivariate analysis. I will take an example and try to explain what exactly these things are. When we say correlation, regression, hypothesis testing, t-test, ANOVA, logistics regression, what exactly these things are and which scenario they are used. And then we'll go for the higher level multivariate. So what rest of the resource person are going to discuss with you in the coming 2 weeks. So let me start with something. The pivotal in the entire statistics is a concept called hypothesis testing. Hypothesis testing, which involves some parameter, non-parametric test, and there is a concept of here as we call it as the p-value. Now, just in the world of statistics, there are certain pairs out there.
I just request all the participants to keep themselves muted, sir, because as otherwise when sir will be conducting the session and there is some disturbance, sabko mute karna padega, 1+ nod. We are allowing to keep them unmuted. आपको permission इसलिए दे रहे हैं कि session थोड़ा interactive और interesting रहे. But if this thing is happening again, I'll just keep everybody on mute. Thank you. Sorry for the disturbance, sir.
No problem. So just pay attention to a couple of words. The word is difference. The second word is relation. And third one is association. Now we use these words along with the words like effect, impact, and so many other words are there, leads to, yields to, etc. But these 3 things are very, very important. Just remember, whenever the word difference will come, we will use a corresponding word in statistics called test. And whenever the relation word will come, we will coin the term as the technique. Just remember that thing. That will be helpful for you. So conversely, if I'll say any test, maybe you have heard of, maybe you haven't heard of, t-test, u-test, z-test, any sort of the test, whenever we say any test, it means I am checking whether 2 or more things are similar or they are different. I repeat, whenever I will say the word test, whatever test, So just you should hear it as that my intention is to ask whether two or more things are similar. Similar means no significant difference, minor difference, very minute difference, or not. Not means they are very much away, very much different, significant difference. So I go beyond the statistical test and I ask you, when you go and check your blood test, what exactly we do in the blood test? When you go and check some hemoglobin level test, maybe the sugar level, maybe the sulfur or other level test, etc. So what exactly we check? So these days in the pathology lab, whenever they give you a report, in the report it is mentioned for a healthy body, this is the parameter. So you will find it most of the cases like this. So one value is written here, one value is written here, and then your value is somewhat here. And now you require to go to the doctor just to understand what it is meaning is and how to take it back to this zone. So it means just try to understand for whatever parameter, maybe it's your BP, maybe it's your hemoglobin level, any other level. So there are always a range is given for any sort of the test. It means what is meant by the range? Range of a healthy body. Range of a healthy body is this. So it means if I talk about the blood pressure, so blood pressure, it's not like for every single person, it has to be in decimal point this value. So we say blood pressure ranges between this and this for a healthy body. It may vary in the daytime, etc. But that's perfectly okay. But if it is less than a particular value, which your doctors and the medical team has decided, then maybe you have a low BP, maybe you have a high BP. If there is a low or the high BP, so we check for the. So I hope all of us are okay with this example. And we have seen in our day-to-day life that whenever we go to a pathology lab and get the things tested, so they check us against a healthy body. They check our parameters against a healthy parameter. And a concept will come here. This concept is called as the null hypothesis. And the null hypothesis, there is one punchline. There is only one. You may later say, no, null hypothesis can be written in a number of ways. I am saying there is only one way to write the null hypothesis. There is no significant difference between dash and dash. So fill in the blanks. So these words are important. There are no significant difference. It means we are not saying that the two things are not different. They might be different, but whether that difference is a major one or it's a minor one, that's the only point. Whether it's a major difference or it's a minor difference. So the test will check that. Okay, so we have certain parameters like this and this range is there. For every single body parameter, we have a range. So if it falls between the range, what will be our conclusion? If some of my parameter that falls here, so the doctor will say you are very much healthy. It falls within the range of a healthy body. A healthy body should have this parameter. Your body also have a parameter. So you are healthy. How to write the null hypothesis here? So we'll write the null hypothesis represented by H0. There is no significant difference between a healthy body and your body. There is no significant difference between a healthy body and your body. And it means now we have something that if my value falls in this range, I hope you are with me. If my parameters fall between this range, we say null hypothesis accepted. I know we are not directly saying you are healthy. You know, in statistics, we make it somewhat complicated, the things, but hope you are with me. Just remember, these 4 or 5 things go hand in hand. Whenever you say the word difference in the statistics is equivalent to test. Any sort of test will be there. Whenever there is any test, there is a null hypothesis. So whenever there is any test, there is always a null hypothesis. And what is the null hypothesis? There is no significant difference between the two groups. So it means for me to say the things are different, I need minimum 2 groups. I need minimum two things. Yes or no? Can I say I live all alone in my house and I don't fight with anyone? That's precisely okay, because for fighting you require two persons. One more person is required. So the word, for the very word difference, we require two groups, maybe any two groups. It can be boy, girl, it can be married, unmarried, it can be state-wise, it can be country-wise too, it can be two time period. Any two things we are comparing, but two are mandatory. Now, interestingly, if I'm sitting all alone in my room, can I fight? The people of psychology say, yes, you can fight. You can still fight between this is what I want and this is what actually it is. Is it right? Intrapersonal conflict. This is what I want at the moment and this is what is happening. But again, duality is there. Duality is necessary for the difference. So can you see these certain things come in a package deal? Whenever you say the word difference, in the statistics, difference means the test. Any test, T test, Z test, F test, we will come to that. But simple, remember, I'm going even beyond the statistical test. I'm calling even the sugar test, blood test, pregnancy test, all of that. Whenever the test is there is always a null hypothesis. Null hypothesis is there is no significant difference between this and this, whatever two things. So whenever null hypothesis, there is some sort of the decision rule. Whenever there is a null hypothesis, there is always some sort of decision rule is there. So what is the decision rule? How we check? So let's note down the 2-3 points for the decision rule. What these points are? So let me write it here. Hypothesis testing, decision rule. How to decide whether this hypothesis will be accepted or rejected. So 3 are the parameters. In the PG level, we teach it something like that. There is a calculated value and there is a table value. If the calculated value is less than the table value, then we say null hypothesis, not rejected. Let me write it here as accepted. There is a slight difference between not accepted and not rejected and accepted. There's a minute difference in that. In all the books, you will find null hypothesis rejected, null not rejected. Seldom you will find the word null hypothesis accepted. But let me take it null hypothesis not rejected as equivalent to null accepted. So this is what we teach in something like the graduation or the post-graduation, whenever calculated T value is less than the table T value. So there is a table value always given for every single test. Then we go ahead with the research, etc. We come to know there is something called the P value also. When we use the software doesn't give you calculated value, they will give, but they don't provide you the table value. So there is a concept of the P value. And here we say when P value is greater than 0.05, null accepted. So this is the second method. Dr. Sanjay, is there any question? Okay. So the second rule is p-value rule. So SPSS call it as SIG, significance value, and most of the software call it as the p-value, one and the same thing. Significance value or the p-value is one and the same thing. Now, is it always 0.05? Well, it is 0.05 in case of social science, management, commerce, psychology, all these, engineering even, it's 0.05. In case of medicine, it is greater than 0.01. In case of animal husbandry, horticulture, floriculture, etc., agriculture, it can be greater than 0.10, 0.10. So this is actual rule is P greater than your level of significance or alpha, you can call. 1 minus alpha is level of significance, P greater than alpha. So in different fields, like in management, commerce, this is decided 5%. A third rule is limits. The softwares, many of the softwares give you lower control limit and the upper control limit. Two limits they will provide. How wide can be the difference between the two? So here the rule is if 0 falls between the limit, between these two limits, 0 falls between limits, then what will happen? We will say if 0 falls between the limits, then we will say null hypothesis accepted. Now, a little technical point here. I will just show you just in some time. See, if you make a x-axis, you know, this is 0, this is positive value, this is the negative value. If I'll say both the values are negative, if lower control limit is negative, upper control limit is negative, it means both of the value must be on the left hand side of the 0, and 0 will not fall in between them. If both of the values are positive, it means both of the value are on the right hand side of the 0, and 0 cannot fall between them if both values are positive. Technically, it is not positive that the lower value is positive, higher is on, upper control limit is negative. It's not possible on the x-axis. So there is only one scenario when lower control limit is negative and upper control limit is positive. We say null hypothesis accepted. So why I'm telling you this rule of limits? Because now there are certain softwares, they don't provide you even the p-value. They provide you only the limits, and you should know how to read the limits. I will show you the meaning of it. But these are the 3 decision rules, and we have written some sort of the 4-5 points here. So whenever you start with a word called difference, the moment you say difference, difference means test, any statistical test. Test means null hypothesis. Null hypothesis means a decision rule, and on the basis of this p-value, you can tell whether null hypothesis is accepted or not accepted. All these things comes in a package deal, they go hand in hand. So whenever any one thing you see, if you are reading a paper and somebody say p-value, if this is written, it necessarily means p-value means somebody has used a hypothesis testing. Somebody had the intention to check whether the 2 things are same or not. Any 2 things are same or not. And there was a null hypothesis which said these are the same, and on the basis of the p-value, you can tell whether the things were the same or not. Interestingly, I don't know what the other person is saying, but simply looking at the p-value, I can think of all these things are happening at the background. And hypothesis testing rule is at the center of it. So let me just show you some results. Though all these sessions will be discussed in detail, like tomorrow, Professor C.P. Gupta, my teacher, he will come and he will discuss with you one way or another. Let me just look for here. I have some data here about the summer, winter, rainy season. This is 3, 4, 5 groups, etc. This is data about some sales. The sales figures are given, advertisement figures are given, some seasons are given, and some territory is given. I want to check whether, listen carefully, I am saying, is there any significant difference in the sales of A and the B territory? Is there any significant difference? It means I have the territory A. There is some sales in the territory A. I can find out mean of the sale. There is a territory B also. I can find mean of this. There is a territory C also, but I'm not interested in that. My query is only territory A and B. And my question is there any significant difference between the sales of territory A and territory B? Just let me try to write it. My objective to check whether there is a significant difference between the sales of territory A and B. Now, if I'll ask you how many variables are there, I should not ask this because it's an advanced level workshop, but if you look at very carefully how many variables are there, just look for, there are so many words. We will start with the Google way. Remove the articles, prepositions, remove the to, between, the, of, etc. all these words. So to check, this is my intention, I will check whether there is a significant difference. Now difference is the word which makes it bivariate. Yesterday I told you there are a couple of words: impact, effect, relation, association, difference, compare. All of them should be there in the objective to make it a bivariate. That's a connector. Now how many variables are there? Weather is not a variable, there is not a variable, significant is not a variable, sales I can see is a variable. Vary. So different companies, different concerns, different territory can have the different sale. It's a variable. And the other variable is not A and B. The name of the variable is territory. And two options are possible, A and B. Two options are there, A and B. So it's a bivariate analysis. We have the two variable, and then there is a connector also. If I'll simply write to check the mean sales of territory A and territory B. To check the mean sales of territory A and territory B, this will be still two variables, sales and territory, but now there will not be a bivariate analysis. Reason being, there is no intention of checking the difference. You simply say, I want to measure about territory A, I want to measure sales of territory B. Use the mean score 2 times, it will be 2 univariate. I assume all of these things are known to you because you are coming to an advanced level workshop. But since it's a revision, I can revise. I can say about it.
Sir, bivariate analysis and multivariate analysis, both are same. Bivariate is part of multivariate.
Yes, sir. Multivariate, as the name indicates, whenever there are more than two variables, that's a multivariate. Variable. Okay. Now tell me, Sanjay sir, if I'll say to check whether there is a significant difference between the sales of territory A, B, and C, is it a still bivariate or is it a multivariate now?
It will be multivariate, sir.
How many variables are there, sir?
Three, A, B, and C.
No, sir. The variable are still two. Sales is a variable, territory is a variable.
Oh,
and
okay.
Territory got the three options now.
Yes, sir. Sales are right.
So only two variables are there. The first thing is you should identify what is a variable. So a variable can be continuous variable like sales, or it can be categorical variable like a category, and category can have the several options. We must differentiate between a variable and the options of the variable. For example, if I say gender, boy and girl, so name of the variable is the gender and the options are B and boy and girl. Variable is still gender. If I in the gender, if I include transgender, it still is a one variable, but now categories are the options are the three.
Okay, sir. Yes, sir. Got it. Thank
you. Okay. So now going ahead, first let's talk about the A and the B. So let's go back. So this is a case of how to know that what sort of tool technique will be applied. This is what I will try to explain you today. In this case, let me give you the answer. We should use the t-test. But the question here is, how do I know that t-test will be applied? Why not regression? Why not correlation? Why not one-way ANOVA or the cross-tabulation chi-square test? So many bivariate are there. How do I know that t-test will be applied? This will be my effort to explain you. But before that, let me just considering you believe me for a minute. So I go here, go to the analyze, compare means independent sample t-test. I want to show you something. So whether sales, that is the test variable, that is dependent variable, and whether the territory, it's asking what define the groups. So groups are the codes. Codes given are 1 and the 2. Now C is also there. The third code is also there, and probably the fourth code is also there. But since I entered value of 1 and 2 only these will be considered. Let's check it out. So it says in the output, a separate file will come for the output. Here it says A, there are the 9 values, and in the B, there are the 8 cases with the B territory and 9 cases with the A territory. Mean of the A territory is 3.22. Mean of the B territory is 4.88. Are they significant different? The three methods which I just explained here, I removed them. First is calculated value of the T. Look at the calculated value. Calculated value is 2.07. Negative sign doesn't matter. T, sign of the T, Z test are not seen, only numerical value. 2.07. Now the problem here is I need to look at the table value of the T. Okay, so if table value is there, I can check whether this value is less than the table value or not. If it is less than table value, then we'll say null hypothesis accepted, no difference. whatever the difference 3.22 and 4.88, these are very minor variation. It seems they are different, but actually they are not. So T will answer it. In case we don't have the table value, we can go to the next column, significance two-tailed, SIG two-tailed. The value is 0.056. Is this value greater than 0.05? Yes. So what was the point there I have written? If P is greater than 0.05, null hypothesis accepted. So what is null hypothesis? That the two groups do not differ significantly. So here the answer is, it appears like this is 4.88 higher and this is lower, but actually they are not really different. It's just a matter of sampling. If you take another sample, they will be same. We can check the third method. Third method is, it is given 95% confidence interval. In the 95%, just look whether the lower value is negative, upper is positive. Is this the scenario? When the lower is negative, upper is positive, we say null hypothesis accepted. When the lower is negative, upper is positive, we say null hypothesis accepted, no difference. So you can use either T method, you can use either the significance method or the limits method. Answer will be same. It is not possible that this is telling something else, second method is telling something else. Not possible. All three will show the same thing. So here our conclusion will be the two things that appear like a got a lower mean, but it is not so. If you take a second sample, they will be almost similar. There's no significant difference. That's the answer. Vikram Singh raised hand. Yes, Vikram.
Yes, I wanted to know that there is a mention of mean difference. This is also to be reported often. And
Okay.
I find difficulty in reporting the mean difference. I want to actually report the mean values.
Okay.
So can it be done?
They see, if you take the difference of this 3.2 to 4.88, the difference is written here 1.65. But so our null hypothesis, how can we write the null hypothesis? I am happy, Vikram sir, you asked this question. The null hypothesis can be written in two ways. Let's try to see that. Null hypothesis is written as x bar of A is equal to x bar of B. I'm saying both of them. I am saying that both of them are similar. Now anybody can look at it and tell these are not similar. Okay. Now Vikram sir, is it possible that the values become 0? In other words, I am saying their difference 1.66 is equal to 0. Is it possible, Vikram sir, that the 1.6 is equal to 0?
Not sure.
Okay. So here comes an interesting concept of the standard error, because we are not programmed that way by nature to understand the standard error or the sigma. Let me give an example, Vikram sir. For example, this is 1.660. My question is, Vikram sir, can there be any scenario when 500 is 0? 5,000 is 0 or 50,000 can be 0. Let's try to see.
Multiplied by 0.
No. I'm saying in different context. My point is, see, sir, actually it depends on the context we are talking about. For example, I'm in the Mumbai and I want to purchase some property on Mumbai. And I went and asked, what is this property? And they said the property is 40 crore rupees. Then I said, no, 40 crore is very high. You please reduce it by 10,000 rupees. Check it again. I am purchasing a property of 40 crore rupees and I say, no, it's very, very costly. You reduce it by 10,000 rupees. The people will laugh and say, when you are dealing in the crores of rupees, then 10,000 is 0. Am I correct, Vikram sir?
Yeah.
Is this okay?
Yeah.
Okay. If I am talking about some like temperature, a body temperature, the variation doesn't go into 10 or the 20. So if 99 is the temperature, but if it becomes 102, it's a serious concern. Just it raised by 3 units, but it's a serious concern. So somewhere it actually depends on where you are talking about. What is the context? So if the context is when you can see my hands, if I'll say this much distance, is this high? The point is, if you're discussing something where we are talking only about this much zone, this distance is way high. But if I'm talking about this much distance context, then this is nothing. Are you getting my thing? Let me give another example.
Yes, sir.
When we draw any vehicle nowadays, have you, if ever traveled by bus, any state roadways bus, so driver is sitting just like I am sitting, and driver is doing this and this on the wheel, okay, on that steering, and bus is going in straight line. Okay, have you ever wondered what is happening? Driver is doing this and this and this, and the bus is going in the straight line. You try to do the same in your car, having some sort of the central gear system or that power steering. In the power steering, you can't afford to do this a slightly, maybe 1 degree, car will tilt at the 90 degree. Vikram sir, why it is happening?
It's called a play, probably.
It's called a play. It means when this much is the play, the driver is doing this, and nothing is happening. Then when the left turn take, driver has to do like this 3-4 times, and the bus will move. In your car, the play is practically zero in the power steering. That's why 1 degree means a great thing. It will turn 90 degree. So the very important thing, Vikram sir, is what is the variations in the data. That is important. Now here coming back, the point is whether 1.66 is equal to 0. Anybody can say this is not 0. Mathematically, this is not 0. But we are talking in the context of the data, territory A and B, which we are talking about. Is this really a great number or is it a minor number? This is my point. So here, my opinion can be different than your opinion. So we go to a universally acclaimed hypothesis testing procedure. The procedure, what it says, sir, it says x1 bar minus x2 bar divided by the standard error given by sigma by this. Can you see from this particular point, this is the formula of T or something. Can you see higher the sigma, lower will be the T? Vikram sir?
Yes, inverse relationship, correct.
Inverse relationship. Higher the sigma, lower is the T, or lower the sigma. It means very almost similar thing. Then the slight difference will be seemed as a very high. For example, let's take some simple example, not about the statistics example. For example, I am a faculty in your department, and every day I reach there exactly dot at 9 a.m. So it's been 1 year, 2 year, 5 year, and one day I haven't come to 9:02. So you should be concerned that why it happened, because the sigma is practically 0. A slight deviation will be a concern that it's 9:02 and he has not turned up. Maybe something serious happened. What happened? You will be concerned. When the sigma is small, a slight deviation will be very high, considered very high. Take another example. Someday I come 30 minutes late, other day I come 40 minutes late, and so on. One day I come 20 minutes late. That's not a big thing for you. Because you say the person comes late, sigma is already so high, a slight sigma will not be considered high. So ultimately it depends on the variation. The most important thing in the data is the variation in the data. So did you understand what is meant by the mean difference?
Yes, got it. So it's a better reflection of our interpretation.
Yes, it is everything to do with the interpretation, because most of us are able to understand 3.22 and 4.88 as the mean score, but none of us can conceptualize standard deviation 1.78, 1.45. Like, what is meaning? Is it like it is higher, lower? What exactly? And standard error, we have absolutely no idea. Like, what standard error is basically spread. How much is the amount of variation? So that's very difficult for us to predict. So we use the software. Software say with the given amount of the variation in the data, the mean difference of 1.65 is not a very great data. It's not a very great data. It's okay. There is a difference, but it's not that great difference. In other words, it means if you take a second sample, chances are they will be same. It's just a matter of chance you took sample from here and there, but they are almost the same. This is what we are going for. Any other questions, please?
Sir, one question regarding significance level. It generally we study if it is less than 0.05, then it would be significant. But sir, here
Yes.
it's greater than, and you are saying
I'm saying there is no difference, sir. When the p-value or significance value is greater than 0.05,
yes,
then
sir.
null hypothesis accepted. It means the two things you are comparing are not different, they are same.
Oh, okay, okay. In that way. Sir. Okay, thank you. Sir.
Right, sir? Okay.
Yes.
Any other question, please? HOD statistics, please ask.
Sir, actually T we can interpret that's the ratio of difference between two means and the standard errors.
Difference in the two mean divided by the standard error. That is
We
the
are
T.
comparing the difference between two means and the standard error, sir. By this way, sir, can you interpret this T, sir? Actually, these are the two differences. We are comparing the difference of two means and the standard
Right.
error.
Right.
Yes.
So what is to be told here?
Hello, sir. Hello.
You are absolutely correct. Difference of the two mean divided by the standard error is the value of T.
Right.
So what should I explain now?
Sir, actually, please explain, sir, the ratio of the two. Say it is greater than 0.05. I mean, the result of T will be depend on their ratio, sir. What will it interpret, sir?
Okay, let's check it out. So here it means x1 bar minus x2 bar is equal to T into sigma by under root n. I hope this is okay.
Yeah.
Right?
Yeah.
Now, in this case, you know, T value is always given for a particular degree of freedom.
Yes, sir.
So let me try to go through some of the. So that's fantastic. People are doing some side by work also.
But I'll just announce once again. I'm just requesting again that please all others keep yourself on mute. Maintain the decorum of the class, really. I'll just point out. I think we have speaking in Muhammad iPhone is there.
Okay, let's go ahead. Anjali ma'am will take care of these
sir.
things. So HOD statistics, if you can speak up your name, it will be really helpful. So
my name is Rauf, sir. Rauf, sir.
Okay, Rauf sir. So see, I'm working. Let's you know, I'm never very comfortable with the numbers and these things. This makes you know, somewhat a disconnect. Let's talk in our language. I want to check the stress level of boys and girls. Stress level of boys and girls. So I have taken 10 boys and I have taken the 10 girls, right? So what will be the degree of freedom in this case? Degree of freedom will be 10 plus 10 minus 2. 18 will be the degree of freedom. Now in this case, I will work on the 5% level of significance. Let's go to the T value. 5%, look at this value and look at the value of the 18. It comes 2.101. The value is available with us. So let's write it as 2.101 into sigma divided by under root. Well, in this case, the formula, because two groups are there, it will slightly change. It will be sigma 1 square by n1 plus sigma 2 square by n2, or the other root like that. But whatever, this is the case. It means, Rob sir, please see, if I know sigma 1, sigma 2, 10, 10, and T value is already known to me, can you see I can find out a magnitude of the difference? What is the difference? This is possible?
Yes, sir. Yes, sir.
It means, sir, I always tell to my student how to read this particular table. This is called as the table value. This table is given in any book of statistics, any book of research at the end of the book. How to, what it means, what it signifies, how to read it. So I say, please read it. This is this value multiplied by the standard error is the amount of the difference that can come between the two values because of natural variations. I repeat once again, and let me write this thing here also. Why the two things are different? What are the chances? What are the reasons that the two things are different? The two things are the two sort of the reasons what we can think is, one is the natural and the second is the some sort of human intervention. Is that correct, Rav sir?
Yes, sir. Yes, sir. Exactly, sir.
So when we go and buy the apples, so you must have seen that we never argue with the person, the vendor, that why all the apples are not the same. Why your tomato, why your potato, all the onions, why they are not same? All are onions, but they are not exactly of the same size. They are similar in size, not exactly same size. So why it is so? Because of the natural variation. Naturally, things are different, they are variation. All of us have the same nose, mouth, ear, and this face, but all of us are so different.
Sir, it is chance error, huh? Chance errors.
It's a chance error, right?
Yes.
So natural variations are called as the chance. But at the same time, there's a one particular farmer who says, no, I have used one particular sort of fertilizer or particular sort of the seed, and it is really improved. That's a human intervention. So either we believe there is a natural variation, chance factor, or we say there is a human intervention. Null hypothesis is always that whatever variations are there, they are because of the chance. Null hypothesis always say whatever variations you are observing, they are just chance factor. If you look any two leaves of a tree, no two leaves are identical. They are similar, not same. If you see any two flowers on a plant, they are similar, rose flower or any other flower, not exact replica. They are not like that. So it means this is the chance variation. So, but there must be some magnitude of the chance variation. So I can say a particular lemon, lemons are very costly these days. I can say lemon can be this much, lemon can be this much, but can I say this is a lemon of this size, of the size of a watermelon? So you will say, no, not possible. So how big can be a particular lemon? How big? By natural variation, how big it can be? This is what is given by the t value, table value. So what is the table value? Table value is you multiply the table value, that is the t value, into the standard error. There are the different formulas of standard error as per the thing. So t into the standard error is the amount of the difference that can come because of the natural variations. So that's why we say we make a rule. And what is our rule? Our rule is if our calculated value, which I check, is greater than the table value. And what is the table value? Table value is the maximum permissible difference because of natural variation. Let me write that. Table value should be taken as it's the maximum permissible difference. So actually t into standard error is the difference because of chance variation. Because of chance variation, that is one. So if your calculation is more than that, do you still call them as this very minute or they are big variations? What do you say? I said this is the maximum that can be, this is the threshold, which can be because of the chance variation. If your differences comes much beyond that, certainly we will say these are the major differences are there, not the minor one. These are called as the significant difference. This is called as null hypothesis rejected.
Yes, sir.
So we have written that calculated value less than table value. So table value is something which we already know. This much can happen. This much can happen. This much maximum differences can be there. If my differences happens to be less than that, then we'll say null hypothesis accepted. And what is a null hypothesis? No difference or minor difference between the two groups. This is the way we work with the hypothesis testing procedure. Is this clear, Rauf sir?
Yes, sir.
Yes, sir. Yes, sir. Exactly.
Okay, right. So now let's go one step ahead. So here basic purpose was simply to tell you what is hypothesis testing, and these 5 things, just remember, these will be really, really very helpful. Whenever the word difference will come, whenever you learn the word difference, any test will come. So whether it's a Z test, T test, F test, U test, chi-square test, normality test, run test, In every test, we are checking whether the two things are different or not. Every test starts with a null hypothesis. It means whatever you are comparing, they are similar. There is no difference. Then there will be a p-value. And the p-value here says, if it is greater than 0.05, 5%. Then we will say whatever you are comparing, I don't know what you are comparing, but whatever you are comparing, that is not different, they are similar. So these things go hand in hand. Always remember that. These things always go together. So difference means test means null hypothesis, p-value. So you can say, I went for the blood test. I wanted to check. So blood test, null hypothesis, I am healthy. And my value, they got outside the range. It means not healthy. Some intervention is required. Medicine is required. It works there also. Now let me talk about this particular thing. Why I am saying a very big statement. I am saying whatever your R is there, same is the T, the same is the chi-square, they are one and the same thing. What I intend to say this, and we will talk of something, a very, very underrated word here. People seldom talk about that in research, that's inference. Inference is one of the most important things which we'll talk now. So let me go ahead. Before that, if any questions are there,
So may I
else I will start the next section.
question?
Yeah,
Hello.
please go ahead.
Sir, as you said that hypothesis, we find out the significance difference between two variables. In some of the studies, research papers that people have written.
Wait. I never said it's the difference between the two variables. Listen very, very carefully. Every word is important. Yes. I said we are checking whether the difference in the two categories are same or not. Not two
Yes,
variable.
Yes,
Please
sir.
see,
Yeah.
when I say marks of boys and girls are similar or not. One variable is gender and the second variable is marks. I am nowhere I am saying that the marks and the gender are significantly different. Doesn't make sense.
Yeah, I'm sorry for using wrong words. Actually, it is difference between two groups and independent variables, right? Yeah, I'm sorry for using wrong word. But in some of the research papers that people have written, I have seen that they have written hypotheses such as there is no awareness among people about XYZ phenomenon. And there
Correct.
And then what they do, they ask questions about awareness on 5-point Likert scale, 1 to 5, strongly agree to strongly disagree. And then they take, say, for example, 3 as cutoff point, 3 average awareness level as cutoff point, and they measure this by applying one sample Wilcoxon rank test. So is this a correct way of writing hypothesis? My first question. And second, in t-test, we can take one sample Wilcoxon test, they take 3 as average cutoff point. So is this a correct to write this hypothesis and take 3 as average awareness and compare the average awareness of respondents with 3 as cutoff value? So these are my 2 questions.
Okay, got it, ma'am. Technically, the people are correct because the procedure say hypothesis is always between the two. You have taken something on the 5-point scale, you have a mean and the other value is 3. You are checking whether there is a significant or not. Procedure is perfectly okay. You can use it and whatever the inference is coming, you can report that. But the main point here is where you will reach, what it will lead to, how it will be helpful if you do that.
Exactly, that is what my question.
Like the mean, it's just like a mean. You said it is not 3. Okay, it's 3.7. Now what? So what significance is there? So you should try to get something like 2 variables, not like one variable against a value. I know people do that. That's technically it's okay, not wrong, but it is not yielding anything, something very meaningful. It's something like, I know this test, let me apply this. It's nothing more than that.
That's what my question is. How can we decide that people are aware if their score is above 3 or people are not aware if their score is below 3? That who are we to decide? But people apply and then they say, yes, people are not aware about particular phenomenon, or they write this as a result. So I was confused that whether we can do that in research logically.
So that's why I love research and very weird reduce. You must have heard of that story of the scientist and the spider. So the scientist was working on the hearing ability of the spider. So spider got the 8 leg. The story goes, he cut the first leg and say move. Spider was moving 2 leg, 3 leg, 4 leg. So cut the 6 legs of the spider. Spider was just trying to move. Then cut the 7 and the 8th leg also. And now he's saying move, move, and spider is not moving at all. So he concluded when you cut the all 8 legs of the spider, it becomes deaf. It is not able to hear. So fantastic conclusion. So this is what is the data analysis and the conclusion. So data analysis is something else and your conclusion is something very weird. People do that, ma'am. But that's okay. Just precisely.
Sir, I think this
Thank
is
you,
a
sir.
case of one sample t-test, wherein, for example, there is a test value. Suppose heart rate is 80 beats per minute, right? If
Yes,
it is
then
above
there it makes sense. There it makes sense. But simply,
that is
ma'am, my
also
point was
technically not wrong. But
no,
yes,
that
it
I
won't
said
conclude
technically
anything.
not wrong. That I said I started with this. Technically not wrong. If we are checking that average weight, just like they check in the fighter plane pilot, they check leg ratio. This particular thigh bone should be this millimeter long. So they can use those sort of the test, etc., to check whether it is there or not. Okay, they can measure directly, no test required. But ma'am's question was about the awareness level. Like if awareness level is coming and you are checking it against 3, then it is not yielding any significant thing. You can simply report mean. Mean is 3.7 and go along with that. But when you are reporting and just emphasizing, then it's okay. Not technically not wrong. They can go.
But sir, in some of the questionnaires, I suppose there are standards which are given. Normative standards, norm-based standards are given. If value is 0 to 3, then you are less stressed. 3 to 4, you are moderately,
Absolutely.
5 to 7.
Absolutely.
So in that case, I think at the master's degree level, we can accept, but not at the PhD level, of course.
Okay. Let me come back to your question. Before that, I have something very important to discuss. I will come back to this question. That's really interesting, and we should discuss it maybe some time later. So here my next point is, I'm starting the second point. One, I try to tell you that hypothesis testing is at the heart of the statistical procedures. Everywhere it will come. So it will be very surprising that I will run regression and you will find a T and the F value written there, P value written there. And you will just remember the 5 things I told you. Now I am working with a particular case. My case is I have the 2 questions. Now you have to listen to this case carefully because I am trying to explain what is the difference between the R, T, F, chi-square test, logistic regression. On that we will build a table and then we'll go to the next table which will be explained in the next 2 weeks. So I'm trying to explain you this particular table where from this comes bivariate, t-test, cross tabulation, and what's the difference between this. So I have a case. The case is, my research question is there any significant relation between sales and advertisement? So please pardon me for writing this sort of abbreviation and poor handwriting. So this is part A, and part B, if so, if there is a relation, what is sales when advertisement is equal to 50? So these are my 2 questions. So for that, I have collected the data. So basically, I want to check whether there is a significant relation. This is what I want to check. A significant relation is there. So you can identify 2 variables. The one of the variable is the sales, other variable is the advertisement. I want to check whether they are related or not. If they are related, then I want to predict sales when advertisement is equal to 50. This is something I want to go along with. So what I have done in this case, I have a data file with me. And in the data file, I have noted down the actual sales and the actual advertisement. Actual sales and the actual advertisement I have noted. So this is sales, this is advertisement. So what I can do in these procedures, we can always, because I say here, whether sales is affected by advertisement. So I'm considering sales as the dependent, advertisement as the independent variable. If there is no idea, dependent, independent, all we can use is the correlation. But when we know, then we go for the regression. Now I know in the PG level, we teach it like this, that write the equation of y is equal to a plus bx. So use some normal equation, summation y is equal to na plus b summation x, and summation xy is equal to a summation x plus b summation x square. Solving simultaneously, we get the value of the a and the b. Put the value of the a and b here. It's something like a 2.3 plus 1.2 into x. This sort of things will come. We are happy up to graduation level finding out the value of the this and this. Right. So now I hope up to this you may not remember the formula, not necessarily the A and the B, and we can write this equation. I hope all of you will agree that this is we can write, we can solve it. We teach up to the PG level. Here we will use software. So now we have a software. Click on the data. There is a data analysis tool pack. So in the data analysis tool pack, I will use here as regression. Well, software is not important. Please don't go for what are the steps, how to do. Please listen to the what is the main crux. So label means don't read the first line, that is a heading. Then output, please provide the output here itself. Click on the OK. I get this answer. Let's try to read out the answer. You know, it's something like, and there are so many values in fact. So allow me to make all of the value up to the 2 decimal place. So I can go to the home tab and reduce down the decimals. Now I have a question, and my question here is, out of the so many values given here, can you see these much values are given here? If I reduce down a little bit size, hope you are able to see all of these values. Out of so many values here, which particular value is giving me the answer whether the 2 variables are related or not? Which value I should point out that this is which is giving me the answer? Anyone please?
Sir, R.
Multiple R, regression.
R.
This multiple R 0.87. So simply, ma'am, see, I take statistics and the research in a very basic level. My question is, are the 2 related or not related? Look at the R and tell me, are they related or not related? What is answer? Yes or no?
Yes, sir.
Yes.
0.87.
So they are related. Okay. So how you decide, ma'am? If it would have been 0.67, then they are still related.
Yes, sir.
0.37, are they related?
No, sir.
So what is your
Weak
cutoff value, ma'am?
relation. Sir, 3 to, I mean, like up to 3, there's no relation. Somewhere 3 to 5, 6, there is medium relation, and we say it is 6 and above relation is little stronger.
Okay, okay, good. That's a good one. Okay, anyone else, please? The same or something else? Why there are so many values written? These values, and these values, so many values are written here.
Sir, I have a point over here.
Yes, please, sir.
Can we take adjusted R square as a kind of percentage that advertisement has an explanation to the sales, that whatever spending we are making on advertisement, that will have effect on sales? Is that the adjusted R square?
That is correct, sir. 73% of the variation of sales are explained by advertisement. This is what we are saying. Now that is correct. But this is not my answer. My answer is, are they related or not related? Ma'am answered that there can be low relation, high relation, but my fundamental question is there a relation or not? She said yes, because it is 0.87.
Yes, they are related because the values are near to 1.
Okay. Okay, I got it. The correct answer is, out of all the value, you should look at this value. Or you can look at this value, or you can at the upper and the lower value. This is the value out of all the values, which is telling that whether there is a relation or not. Not this value, not this value. And secondly, ma'am, this is multiple R. There must have been some meaning of multiple. It is not that R. It is R, but it's a separate R. Okay. So it's again Karl-Pearson coefficient of correlation, but it is not between X and Y. It is something else.
Sir, I have a query, please.
Yes, please.
Sir, what does it mean that whether if I'm going to check the relation between the 2 values, Whether they are related or not related, it will be given to us by T statistics or P value, what you have colored. And in terms of the explanation, then we'll look at the regression statistics that's called the R values. Am I correct?
Okay, let me explain, sir. Actually, there is nothing else in the statistics other than R. And recently, I have written a post. How many types of R are there? There is only one thing in the entire statistic. That's R, and it comes in the different phases. I could find up to 31 types of R. 31 types of R which are possible. Let me try to explain you, sir. First thing is, we will say here, yesterday I told you that whenever we have two variable and we say what is the relation, we can use R. However, if we know there is a DV and the IDV, then it will not be R, it will become B.
Yes,
First
sir.
is we will focus on the B. Now I am saying with the null hypothesis that B is equal to 0. Okay. Now before that, let me try to ask one thing. So Dr. Yashpal, can I ask you something?
Yes, sir, please.
Sir, my simple question is not a very technical question. This value of 19.24 and advertisement coefficient of 0.96 comes with this particular data set. Right, sir?
Yes, sir.
If I'll add one more value here, any arbitrary random value, will these values be same or they will be different?
So what I believe that must be changed. Something
They must be changed, maybe up to the decimal place, but that will change.
Perfect, sir.
Right? So some of the people are not able to answer. They say, how do I know? For them, we can put it very simple. All these values, they start from by taking their mean score. So I simplify my question. There is a mean particular of this. The mean comes out as something like, where is the mean? 33.3 is the mean of these values. My question is, if I'll add any value here, the mean still will be 30.3 or mean will be changed? So mean will be changed. I think there is no doubt to that.
Mean will be changed.
Mean will be changed. Maybe minutely it will change, but mean will be changed. So Dr. Yashpal, my question is, why I should believe your results? Because your results are valid only for a sample size of 12. You yourself are telling me that when the sample size will be 20, 30, 40, something, these values will change.
Sure,
so why
sir.
should I take your results seriously? Why should I believe your results?
So I believe as the, I'm talking about that if the number is increasing, what we say that whenever you want to trust on the result, you increase the sample size. So as much as large is the sample, then your results will be more and more accurate. So in this case, if my values are 10, then whatever is there, that is clear. So when you are adding more values, I believe it will give more certainty to the series.
100%. 100%. But as maybe sample is of 300, you add 100 more value or 50 more value, the value will change. My point is this.
The value will change, sir.
So here we are writing it as sales is equal to 19.24 plus 0.96 into advertisement. This is what we are writing. And my objection or my observation here is, why should I believe this value? Because you yourself are saying that this value is always subject to change. Right, sir?
Yes, sir.
So here, please look up to the PG level. We are happy by simply finding out this value. Now in the research, sir, we are going one level ahead and I am asking a very different question. I am asking a question, will there be any scenario when this value is 0 in the future? Listen what I am asking.
Yes, sir. Yes, sir.
Is there any scenario when this value is 0 or this is 0? So I'm not asking what this value is. I am asking you, please tell me, my objection is, my concern is A is equal to 0 and B is equal to 0. This is what I'm checking. Number one, I am least concerned about what will be the value. I'm not really interested in that.
Okay.
I am just saying, is there any scenario this can be 0? This is what I'm looking. So first question here comes, okay, what is meant by A then? When we written 19.24, what exactly is the meaning of it? Let's try to understand about it.
Okay, sir.
I hope all of you are with me. So I want you, if you have some copy and pen with you. If it is possible for you, I want you to draw a chart of age and the height of the baby.
Sorry,
Thank
sir,
you,
I'm
Niti.
muted, sir.
No, I will thank you, Niti, for the message. So Niti gave just a very important message. Now came back. Please try to draw age and the height of the baby. Draw a line chart, not the bar diagram, etc. Draw a line chart. What sort of line chart we will make? So most of the people will make it something like this is the chart. Somebody will say, no, this is the chart. Okay. But here, just try to think over it. I want you to think, if a baby is born dead, a dead baby is born, will there be any height of the baby or there will be no height of the baby? I want you to ponder upon this question. Even a dead baby will have certain height. So is it possible when that a baby is born, the height is 0? Does this make sense to you? Or you will say, no, there will always be some height of that will be there. And then in the initial year, height increases very fast. And then after some time, it doesn't increase, become a constant, something like that. This is the age of the baby and the height of the baby. Your own age and height, if I make a chart, my age and height, if I make a chart, something like that. At the time of the birth, there was some height, and then it increased faster and then doesn't. Now, my question here is, now look and tell me whether this particular thing is called as A. A means this is the value when independent variable is not there. Dependent values still have this value. That is called as the intercept. That is called as the intercept. When the independent variable is 0, no independent variable, then dependent variable will make sense or not. If you say no, there should not be. I see a fantastic example in the book of Andy Field, how to explain. He says, most of the time we say, no, intercept is mandatory. People don't think. Like somebody, it says that some body parameter, let's say X is equal to A plus B into the heart rate. And the person asks, when the heart rate is equal to 0, what is the parameter of X? Naturally, it will come some value. But now this Professor Andy Field says, when the heart rate is 0, don't you understand the person is no more? When the heart rate is 0, person has already died. That what is the meaning of that parameter? Where is that parameter? What is that meaning? It's meaningless. The person is already dead. So in this case, you say, no, there is no such thing. A will be 0. A will be 0 in this case. Or in other words, I am saying, when you have a data set and you draw a line, all the software packages are designed to have a compulsory. Listen this point once again. I am saying all the software package, they are designed if your point are like this. Now, can you just see, actually this seems to be a line passing through the origin. Should be like that. But since all the softwares are designed to have a line, a intercept value is compulsory. So what software will do? Software will try to make a line from here. How the software will tell you that, hey, this A should not be there. So it will simply make this particular value, look at this particular value, P value less than 2, or this P value greater than 0.05. So here what we are saying, how to read this output, not from the start, right from the bottom. Right from the bottom, the first thing, how do you know there will be intercept? Can you look at the data and can you think of whether it is passing through the origin or not? Can you do that? I can't. So I depend on the software. I ask software whether this 19 intercept should be there or should not be there. Now it has checked, it says, what is the null hypothesis? This value is equal to 0. This is a very minute value, 19. Again, looking for the variation. The procedure said no. P value is less than 0.05. Intercept is a robust value. It must be there. When your X is 0, when there is no advertisement, even then everybody will have a sale of 19.24. By the simple point that you go to the market, you will have some sales whether you advertise or not. This is what is apparent from the data. I'm not saying this is universal truth. This is what the data is saying. Then secondly, I say, so this is the explanation of what is intercept. Intercept is that value when your independent variable is not there, whether there will be dependent variable or not. You think of yourself. Since all of you are in muted mode, you can just think and answer yourself. I say performance depends on the leader. My question is, if there is no leader, leader has gone France for 2 months, will there be any performance or not? If you feel that why we should go to the company, nobody will go, nobody will work, then it means in your case, A should be 0. The data passes through the origin. But in most of the universities, etc., you will find everybody is doing their own job. Whether the leader is there, no there, everybody know what they are supposed to do. There will be a certain level of performance. And after that, if leader is present, certainly it can improve. If even no leader, there is a presence, it means you agree there must be a intercept value. So intercept is that value when X value independent variable is not present, whether still dependent variable will have certain value or not. This is called as the intercept. Now the second thing comes, and the most important is my question, case A1. Is there any relation? So we think of relation means R, but I told you when there is a dependent and independent variable, we don't call it R, we will call it with the name of B. You remember that? I said yesterday that please see, tomorrow I will ask you, tomorrow I will check whether B 0. And I gave you a formula also, if you remember. What was the formula? The formula of R and B, relation of R and B was R is equal to BXY into BYX under the root. It means you are asking me, or the question is whether there is a relation. I'm not checking R, I'm checking B. But just see, if I say answer somehow comes yes, answer comes yes, it means any of the B is 0, and when you put R will be 0. If I'll say answer comes, if answer comes no, it means it's not 0, it means these are not 0, there is some R. So what we are doing, the question I am framing is there any relation and who's answering? So Dr. Yash, ma'am, please note, it's not the value of multiple R, it's not the R square, it's not this value, not the anything else. This particular thing, I am saying 0.96 is equal to 0. This is just, a minor value. This is not really robust. Who will tell? T is the boss here. Remember, the real boss of the hypothesis testing or in entire statistics is the statistical test. This value of 5, that says me this value will not be 0. How much this value will be? It can be 0.96 plus minus something. It can vary. It can vary. I'm not saying that it will be, if you increase sample from 12 to 20, it will always be 0.96. No, I'm not saying. Look at this value, lower and the upper. It can be as low as 0.52. It can be as high as 1.4. It's not like it will become 20 or it will become 0. I'm not saying. With this particular data set, if the amount of variations are the similar, it's not like some outlier may come, any arbitrary value, not that. If the similar set of data will come with the similar variation, this value of 0.96 can be as low as 0.52. It can be as high as 1.4, not beyond that. So see, when the IPL matches are there, they say, okay, in the 10 over, they have made the 80 runs. They never say they can make in the another 10, 500 runs or 1000 runs. They will say their score can be between 150 to 170 with the same sort of data. Now, technically, you can say, no. 10 over means 60 and multiplied by every ball, there is a 6. So 360 runs can be made technically. Yes, can be made, but is it possible? Normally going forward, just like you played similar or maybe slightly better, it can be between 150 to 170, 180. Likewise, I am saying with this particular data set, with this much variation, I can predict in the future, it can be this value, the relation can be as low as 0.52, as high as 1.4. Okay, this is what is the B value. And B value, we can compute the R value. And what is this multiple R? It is not the relation of X and Y. It is the relation of Y and YC. This is the actual value. Now, since I have this value, can I predict Can I predict the sales? How to predict the sales is equal to A plus B, this is B, into X. X is this. So my question here comes that when advertisement was 25, I know actual sales was 25. But what is your prediction? What is your prediction? I know this actual advertisement, this is the data available with me. When actual advertisement was 25, sales was 51. But according to you, what will be sales? My answer is 43. What others? It was 71, it is 67, 39, 37, 42, 48, 48, 42. Never matching. So you might say, what sort of prediction is this? It is never matching, 41, 51. But I will say, just check their total. The total comes 512 and check its total. It is also 512. It's also, try to see what is happening. Though there will be a complete session on regression, maybe I am entering into that resource person's domain. Just let's try to see what is happening here. And then I will take your questions by unmuting. My actual data set is something like that. With that, I plot a line. Oh, not at this one line. Let me put a straight line here. So I put a straight line with this and write its equation also. The equation is y is equal to a plus bx. Now you are asking me, see what sort of data is there. Somewhere it's a higher, lower, higher layer. It's not matching. Why it is not matching? So let's play with the simple sort of a game, something like that, an exercise. Let's assume I am the consultant and you are the particular let's say sweet shop. You have a sweet shop. You started a sweet shop and I am your consultant. So on the day one, you asked me, sir, how many samosa I should make? I said, okay, you go ahead and make the 25 samosa. Okay, so this is the number which you will prepare, and this. So you prepared 25 and the demand was something like higher. Then next day I said you prepare this much samosa, demand was here. So actually what I am trying to say, this is what is actual things going on, and what I am predicting is, I am predicting only in a straight line. At what I am predicting, it goes like that. Sorry, line is not taken, the red color line. This is the line I have drawn. This is what is going here. See, when we say this particular thing, here it is 51, my prediction was 43, 71 prediction was 67, 39, 37, 42, 48, so on. Why they are not matching? I'm just trying to explain that. When we said, I said go for this much value, this one is predicted and the black one is actual. Why they are not matching? They are not matching because the real life variations are not linear. Please try to understand. The real life variations are not linear. They can be anything, but I am trying to predict by a straight line. Yesterday, somebody asked a question that whether we always go for a straight line in linear, etc. No, never. It can be curvilinear also. If you want, now what is happening? I said you produce this much, actual was this. So there was something mismatch. Then I said produce this much, this was the less of the sale. So what is happening? You remember that concept of inventory where we called shortage cost and some sort of holding cost. Here the demand was high, I produce less. There is a shortage. Next day I produce more, the demand was less. So whatever the less was there, I can send, if it is possible, I can send to the previous day. Here demand was high, here demand is this much, here demand is this much, this much. But at the end of the month, end of the time period, you will find summation of actual is always equal to the summation of the predicted. It will always be true, always. The procedure is designed in such a way. That's why, because of this reason, when we say actual minus predicted, this is called as the residual. That's why summation of the residual is always equal to the 0 for this particular reason. Okay, so if we just go for their difference, it will be somewhere positive, somewhere negative, because totally same. The difference, if I total, that will be 0. And this particular 0.87 is basically the relation between this actual sales and the predicted sales. It's not between the X and Y. Please remember that. It's not between X and Y. It is between the Y and the YC. So what are the important things in the regression that are really important to us? Number one, we are not really concerned with these values, because I know when we go for the larger data, these values will change. This 19.24 can go as low as 3.96. It can go as high as 34 if the same level of variations will continue. And advertisement of 0.96 currently, which this data is showing, further data can go as high as 1.4, as low as 0.52. But this is a guarantee, this is a surety, this value will never be 0. This is what we are referring. And this is what my research question was. Is there any significant relation? Answer is yes, there's a significant relation. Out of all such thing, what I believe is the hypothesis testing test. I believe the p-value. I believe it, because if it is telling me that's what's likely to happen. Will I be 100% correct always? No, 95% I will be correct. 5 times I admit there can be mistakes. That is called as the level of significance, 95%. 5 times this can be total googly and I can be grossly wrong, 5% of the chances. Nobody can say we will go for the 100%. I just explained 2-3 things here. One, I explained what is the meaning of this one. We calculated it by someone. In the PG, we are happy just by finding their values and write the equation. The moment we come to the research, this becomes meaningless, because the value will always change. So we are more interested in the t value or the p value. Check the table value. If it is more than that, then fantastic. So what is the null hypothesis? I told you null hypothesis is always written, there is no significant difference. Here we change the null hypothesis in the form of A is equal to 0. There is no significant difference between intercept and 0. And second, B is equal to 0. So for each p value should be less than 0.05. If that is less, we are happy. We say our model is robust. What if the p value of this B is greater than 0.05? It means this variable is not influencing the dependent variable. Better select something else. This is no evidence found from this data that the two variables are related. Okay, now you can ask your question. I will request Anjali ma'am to unmute you, all of you, and then you can ask your question.
Sir, everybody can unmute and ask questions.
Oh, they
I have
can
not put any
unmute.
restrictions, sir.
Okay. You are very kind. Yeah, please ask any doubts, any queries.
Sir, you have very well explained about this coefficient and t status. थोड़ा सा sir standard error का भी rule please.
Okay.
Let me know.
Standard error, I will not explain in detail the mathematical calculations. Let me just simply tell you, standard error basically means how much is the spread. So what is the spread here? So this particular thing from here to, where is the second line? This particular thing. So this sort of spread, this thing is called as the standard error. So higher the standard error, it means lower the standard error means variations are very, very less. And the points, like hypothetically think, if all the points are like this, standard error is 0, all the points will be on the same line. Standard error denotes the spread. Higher the standard error, then it means lesser will be the predictions. Lower the standard error. But the point is, we are not, that much programmed by nature. Our brain doesn't have that wiring. We understand standard error. So we just look for this is the amount of the variation.
Got it, sir. Thank you so much.
Okay. Any other questions, please?
So, may I ask 2 questions?
Certainly, yes.
Sir, I have my first question is a hypothesis in regression. We study the impact of independent variable on dependent variable,
Yes.
and if the t value or p value is significant, that means independent variable has significant impact on dependent variable.
Yes.
So if there is no relation between variable, this value will not be significant. That is what I have
Yes.
understood. Am I correct, sir?
This value
So
will be, P value will be greater than 0.05.
So we don't need to look for R value in regression
Absolutely
test.
nothing. Absolutely, it becomes meaningless to check any other thing.
Okay, sir.
If
My
this
second
value is greater than 0.05, rest of all is null and void.
Okay. My second question is, if R square, that is variance, a independent variable, suppose if I'm getting it is say 16% or 17%, is
Right.
this variance significant enough to continue or to, to write the, to go ahead with the regression result, or that is an indication that I need to incorporate more variables and start study all over again?
Okay, the answer will be given by P value and the T value. If it is significant, even 1% is okay. That is perfectly okay. Even 1%, if it is significant.
So if the variance is 16%, that is R square is 16%, and even if it is 8%, I should always go ahead with P value.
100%.
It is significant or not.
100% correct, if it is significant. And let me just try to show you, because you asked a question, let me simply go for generating some random variable and try to show you that how these values will come. So between 1 to 10, I'm just generating the 10 values. So generally you will find with this one, if I'll find their correlation, what is their correlation? This is the first one. This is the second one. Correlation is 0.43. Oh, it's very high. So what should we do here? We should do it as, change some value here somewhere. So if I'll make it as this 0.3, I have to actually disturb them. So that it seems there is no variation, 0.3, and with the 4, it comes as 9, right? Now almost 0. Now shall I try it? Regression. Okay, so y is here and x value is here, and my output should be given here. Okay, so check it out, the p value, let me make it up to the 2 decimal place. So p value here comes as 0.99, greater than 0.05. It means all other values becomes meaningless, all of them. There is no point in checking any other value. And see, R is also coming very, very less. But here the simple point is, if it is significant, rest all the values make sense. If this value is greater than 0.05, all other is null and void. It's meaningless, completely meaningless.
Thank you, sir. Sir, one more last question. I'm extremely sorry for asking too many questions.
Ma'am, always say the next question, not the last question. You can ask as many questions. Absolutely not a problem.
Sir, I have seen people apply regression test on Likert scale, that is from strongly agree to strongly disagree.
Right.
But then Likert scale, and then for normality is a precondition for applying regression. And when the data is collected on Likert scale.
Wait, ma'am, wait. Who said normality is a condition?
But sir, regression is a parametric test.
But
So
have you seen any book? Have you seen any book, ma'am? No, you haven't seen.
Remember.
Normality of the residual should be there. Please
in regression.
Please read once again. There are the 10 assumptions for the regression. Some assumptions are for the residual, others are for the variable. Okay. In the residual, we say residual should be normally distributed, not the variables.
That is only in case of regression. I mean, like for parametric, it is normality of dependent variable.
Of the dependent variable category wise, right?
Thank you, sir. Thank you very much.
And ma'am, we should always ask, like, what will happen? What will happen if we say that normality is not there? Normality of residual is not there. Let's try to understand what is meaning of that. So here I will say, this is my one line, and this is my second line. So somehow, and this is my equation of the regression line. And I have some of the data set like here, and one point is here. Okay. Now what is happening if there are like only one point is here, ma'am? So all of the, actually you see, if this point is not available, your actual line should be something like that. But because of this single point, the line will go like that, because it will try to manage, it will go through the middle of all of them. So it means so many variables are contributing this much residual, and this alone is contributing this much residual. Okay, so what is the indication, ma'am? In other words, what they want to say when they say residual should be normally distributed, it's in other way and checking whether you have got an outlier or not. The biggest enemy of the regression is the outlier. A single outlier can change entire result. So be very, very careful about the outlier. But again, if you are working on the Likert scale, there is no concept of outlier. Outlier is a real number. Outlier is not a error. It's a real number. So in Likert scale, how can there be outlier? No outlier possible. And secondly, whenever you use the Likert scale data, your R scale never comes 80%, 90%. It hardly comes 20, 25, 23. That's it. 17, 20%. People
Yes,
will
sir.
appreciate it. It is never 60%, 80%. If somebody say I use Likert scale and it's 80%, the person is lying and done some manipulation in the data. Not possible. Generally doesn't
Yeah.
come.
Yeah,
Sir.
that's why I asked that question of R square 16%. Thank you, sir.
Sir, generally p-value is less than 0.05, then we say it's
Yes.
significant.
Yes.
What about the benchmark for t-value, sir?
Sir, t value is to be checked. See, check it out here, sir. So,
Oh, okay.
so you know, there is a movie, 20 साल बाद, having a song, बैठ मेरे पास तुझे देखते रहूं. So let's try to, you know, sing that song along with this t value. Look at this value, sir. So when degree of freedom is 1, it's 12. When degree of freedom is 2, it's 4.3, 3.1, 2.7, 2.5, 2.4, 2.3, 2.1, 2.1, 2.0, 2.0000. Then on a 62, on a sample of 120, 1.98, or for very large sample infinite, it's 1.96. So what I understood,
it depends on variables, number of variables, number of parameters.
Sample size.
Sample size.
Number of variable is different, sir. See, here in this
sample
case,
size.
number of variables are 2. My
Two,
sample
but
size is
sample
12.
size.
Sample
Yes, sir.
size.
Sample size means if it's
Sample
more
size.
than 30, then
Right.
okay, sir.
One more point here, sir. If you look closely, for only the first 3 degree of freedom, got a value of 12, 4, and the 3. Rest all are 2 point something, sir.
Yes, sir. Yes, sir.
All are 2 point something. So there you will find many professors saying that t value always considered as 2 point something. So if I read it out here, t value is 2.9.
Yes, yes.
There are great chances. Like I'm 100% sure about t value 5. If
Yes.
my value is 5 and table value is 2 point something, calculated greater than that value, null hypothesis is rejected.
Right.
Right, 2.9 almost rejected, but you can look at that table. That's why p value is very, very good. Problem with
Yes.
the t value is if the value comes 2.12 something, we are not sure. We are
Okay,
doubtful.
sir. Okay, it's a less than 2, then we are not sure. Okay, sir.
Yeah, it's a 2 point something, we are not sure. But if it is like coming 1.2, 100% sure, it's less and no, the whatever two values you are comparing, that is 0, not same. No, they are almost same. If it is 3, 4, 5, we are same. Only for the between 2 to 3, there is some sort of confusion, and there we look at the p value.
P value, right, sir. Fine, sir. Got it, sir.
Okay.
Thank you, sir.
So let me stop with the t only this much, because the next resource person will explain what is meant by 1313, what is 1000, how to 25, and what other things are taken. So we will see it later. Just one thing, please allow me to share. This t value into the t value, t square, is called the f value. Can you compare this? So when there is one dependent variable and one independent variable, then t square becomes the f. So it means never ever think like t will tell you something else and f will tell you something else. Never possible. Whatever's on the same data set, if you apply t, if you apply the second one, that is called as f, you will always get the same answer. Answer will be same always, because t square is f. There is no difference in that. Now let me come to, shall we take a break here? A short break?
Yes, sir, we can take a break here, sir. And we'll come back, I think after 10 minutes, sir.
Oh, 10 minutes.
Or 15, sir.
I will do.
And I
5
would
minutes.
just like to, because there are some participants who are very concerned that, the others don't mute themselves. My request to all the participants, we are all mature enough to realize that the resource person will be inconvenienced if our microphones are not muted. So therefore, please, I think in all fairness for Professor Kaushik and to understand what he's saying, because he's, the kind of brilliant teacher that we've got for you. I would be extremely grateful to each one of you that please mute yourself, because as co-host, I can mute everybody, but then that means that I would be muting the resource person also, which is going to be very unfair. We don't want to be unfair to our participants, but we all want to be, I think, responsible enough to realize that we could be disturbing the resource person. So with folded hands, I'm requesting every one of you to please make sure that there is no disturbance that we create for our resource person. And I think your session, as always, Professor Kaushik, a person like me who's still not so technologically, I would say, so efficient and effective, but yes, yet I am able to absorb what you say. You make it so simple and so lucid. Thank you so much. In any case, 5 minutes, we come back and meet again. Thank you so much.
43 we will start.
Thank you
Please, sir.
so much, sir. We are coming back in 5 minutes. And thank you, Rekha ma'am, for the input. I just request all the participants to keep them logged in only so that we don't have any problem. And we come back in 5 minutes, as sir has said.
Yeah, please,
Thank you.
yeah, please,
Thank you.
please keep logged in.
Anjali ma'am, can I ask a question to you?
Yeah, please.
Ma'am, the videos which are available on the MOOC course on the platform, they'll be available till 12th. Can we see these live videos post 12 also somewhere?
Ma'am, post 12. Ma'am, most of the videos, once the courses finishes, then the videos will not be available. You will not be able to even have access to the MOOCs platform. Many
Yes.
videos will be continue to be available on the YouTube, official YouTube channel of Ramanujan College. So you can have a look
Okay.
from there, ma'am.
Yeah, suppose later on we want to come back and check out something and
Ma'am,
revise
many
a bit.
videos like the official Ramanujan College will have many videos which are there right now that are being put up on the MOOCs platform. But once the course finishes, ma'am, then definitely no access is going to be there for the MOOCs platform or the videos that are there.
Okay, thank you. Thank you.
Ma'am, hello.
Yes, sir.
Ma'am, was any MCQ or assignment for study class?
Sir, yesterday, the assignment for yesterday, once you have a look at the video, at the end of the videos that are being uploaded on the MOOCs platform, the assignment is always there. Like the file which is having the, आप वहीं पे देखिए सर, जो डे के सेशन है उनके साथ ही वहां पर असाइनमेंट भी आपका MCQ का जो है वो वहां पर अपलोडेड होगा सर.
Yes, ma'am, I have already seen it and there are 6 questions probably if that is the, yeah.
So sir, you the assessment is going to be, sir, only on the MOOCs platform, and whenever we are uploading the video, a separate file with the video is always being uploaded where you can attempt the test that is being put up.
Okay, ma'am.
Okay, is it okay, sir? But I request all the participants to please register yourself on the MOOCs platform. And if you are having any problem in this regard, I request you to please message me or Dr. Dayal so that we'll just forward the same to the technical team and they are able to take care of it.
I am facing problem, ma'am. I'm unable to register.
Sir, whatever, Sanjay sir, whatever is the problem, as I requested, Shaifa ma'am was also facing the problem. I just request you that these are the technical issues which happen. You have any problem, just send me across your name, email ID, phone number, and along with that, the screenshot of the problem that you are having, and the technical team will get back to you, sir, because we are the one taking care of it.
Okay, ma'am, on email I have to send.
No, sir, you just send me across on my WhatsApp number because that will make the things faster, sir.
Well, your WhatsApp number, where will?
So it is there in the brochure. I'll just share it one more time.
Yes,
And
ma'am.
sir has, Dr. Kaushik has also shared in the chat box his YouTube channel also, which is there. Sir is very has actively put up many videos on that, on research methodology, and really interesting to watch.
Please, ma'am, share, ma'am. Yes.
Anjali, ma'am.
Number is here. I'm
Please,
just
ma'am,
putting
share
it-
your number.
Yeah, I'm just sharing. I just request you all to please message me, because that way, whatever is the problem, I can send it to the concern. Just if you call me, sir, or something happens, I just assure you, and then the problem still persists. So I just request you that please message me along with the problem that it is there, so that it will be easy for me to send it across to the technical team and the things are being done.
Fine, ma'am. Fine, ma'am. Thank you.
Anjali, you can send my number also in case.
I'll just do it.
Yeah.
Anjali, ma'am, Sahifa, I spoke to you. I have already, yeah, ma'am. But as you said, that assignment for yesterday are already been uploaded.
Ma'am, Shaifa, ma'am, they will be available for some time. It is not.
We'll get time. Okay, ma'am. That's what the question.
But don't wait endlessly, ma'am, because what happens if there is a time gap of a certain period, then you may not be able to access those assignments, and it becomes difficult. We try our level best to reset them sometimes, but it's not easy to do that, most this thing. Therefore, it's always good if you are able to just finish them along with it.
Yeah, ma'am, but actually I'm unable to log in. I have already forwarded my problem to ma'am on WhatsApp. So that's the reason I asked that whether I will be able to.
That we looked into positive.
Thank you, ma'am. Thank you very much, ma'am.
Ma'am, if your problem is not being sorted out by tomorrow morning, just let me know, or drop a message to Dr. Dayal. Her number is also, I've just shared here. So you can
Yes,
message me to either of you, and we'll just, either of us, and we'll just try to sort out the things for you, ma'am.
Sure, ma'am.
But
Thank you
again,
very much.
requesting, ma'am, it is not just that we don't want to talk to you, but the only thing is, हमारे लिए थोड़ा आसान हो जाता है problem sort out.
No, I can understand, ma'am. Thank you, ma'am.
Thank you, sir. I think we have sir again, ma'am. So we welcome you once again, sir. I think these are the disadvantages or the advantages of having the online teaching, like the way we face it as a resource persons when we are coordinating. So all assessments and everything, there are a lot of problems. And I think as teachers, we all are required to learn about the MOOCs platform and how we operate it, because ultimately we have to do the courses and assessments through it. So we all are learners here, sir, and we welcome you once again, sir, for this session here. And as requested, I request all the participants to please maintain the discipline so that we to conduct the session smoothly, sir. Thank you, sir. Over to you.
Okay. So, ma'am, you are wonderful host. Both of you are just excellent. And on behalf of all the participants, let me take this opportunity to thank you for your patience and continuously helping sorting out their problems. I know in online session this is always a problem, but you are wonderful people. So let me get back to this. I don't know whether participants were able to take a break or not, but let's talk of something else. So what I explained, if I'll summarize, we have the two variables. Look, everything emerged from the objectives. My objective was to check out whether there is a significant relation between sales and advertisement. I can precisely look at the two variables. Both of the variables are continuous. Sales is the actual sales, advertisement is the actual in the numbers, maybe rupee terms or something like that. My objective is to check their relation. Now, it doesn't matter whether you write the word here as the effect or impact of advertisement on sales, or write the association or write the influence, doesn't matter. So these are the things for the English, but statistics doesn't give any weightage to these things. Statistics looks only for these parameters. How many variables are there? 2. Do you know their role? Are there any dependent, independent? Yes. In this case, we feel sales depends on advertisement. Second point. Third point, are they metric or non-metric? How you measure them? So looking at the data, I can say these are the ratio measurement, and it is metric or continuous measurement. The third point. The fourth point is this is a bivariate. Two variables are there. I'm checking their relationship. So you can look at my table. In the table I have written here as, when we have the two variable, dependent is metric. There is a concept of dependent, independent. Dependent is metric, independent is metric. We should use simple regression. In the red, I have written the address in SPSS. So I have written correlation also here, but correlation is used when there is no concept of dependent, independent. Then we use correlation, but here is the case of the simple regression. So now let's go ahead and say we know regression, and why to learn about the t-test, ANOVA, etc. We know regression, and that's a good thing, and it's a very powerful thing. And would you like to answer the second one here? I can write down the equation as y is equal to what it is, 19.24. Y is equal to 19.24 plus 0.96 into advertisement. And I can answer it here when advertisement is equal to 50. So let me try to put it, the answer here is equal to this plus 50 into this value. So the answer is 67.22. So my answer here comes 67.22. Just remember that, that's an important point. So I have the answer of both. Is there any relation? Yes, there is a relation. Who told it? The t-test told it, of the variable, independent variable, or the p-value. They told there is a significant relation. So on the lighter side, I say, you know, when there is a marriage procession is going on, Bharat is going on, then there are the 300, 400 people. Then you have to identify who's the groom. So groom is the one who's sitting on a sort of a horse, that is the groom. So out of so many things here, what is the value which will answer? The t value and the p value, that is the most important. That answers, and then other things will come into the picture, not the other. If this value denies and this multiple r is something, that is meaningless. If t is not greater than 2, if p is not greater than, not less than 0.05. Now let's go to the second part, and let me remove all of this. And I come forward with a problem here. I still have the same question. I still have the exactly same. Is there any significant relation between sales and advertisement? But the problem is, when I approach the people refuse to share their advertisement with me. Okay. Is it possible? Yes, it's possible. People refuse to share their advertisement values with me. Now what I do? I have to collect the data. I simply ask them, okay, you simply tell whether you used high advertisement or low advertisement. So I simply said advertisement less than 33 will be considered as low, more than 33 will be considered as high. I went with this one. Okay, 33 is the parameter to decide the low and the high. Now we know of here in this case, the first case, we can also go like that. Go to the first, select both the variables. In Excel, we can go to the insert, this one chart that is called as the scatter chart. Click here. Now this is the sort of the lines which we can see. And if you want to, Excel will help you. Click on this, there says trend line. Click on the trend line. There comes the line. You know, we were working so hard for this. Excel says life is so easy. And further we can go for the, in the linear, more option. We can further say it as display. Can you see at the bottom here? Display equation on the chart. This is the equation 0.95 into 1.24, and display the R square also. R square comes 0.7616. Everything is there. Okay, so this is the regression equation. We can draw the line and the answer is available with us. So, but Excel doesn't like this on the chart. It doesn't provide you that p value. Yes, Mr. Kumar has some question. Yes, please.
Yes, good evening, sir.
Good evening, Sharmila.
Hanji. Sir, can you explain R square? There's so much confusion regarding R square.
Yesterday I told you R square is basically, you consider it what is common in both of them. That is R square. Because I require a lot of time to explain. Tomorrow, my teacher, Professor C.P. Gupta will come and he explained regression in 5 to 6 hours. So if he come to know that Neeraj explained it in 1 hour, I will have a hard time because it's so much to discuss about it. For a shortcut, you simply remember these are the variations in the Y. This is X. how much the variations of X are shared by Y, explained by how much variations of Y are explained by X. This is called as the R square, the common portion in both of them. For shortcut, you can just understand that.
Hanji sir, adjusted R square.
Adjusted R square, first it's adjusted. Why it is adjusted? Because there is a problem with that of R square. There is a very interesting story about it, but again it will take a long time. The story goes like this. There was that was the year 1949 probably. One economist in South Africa works with GDP as the dependent variable and 49 variable as the independent variable. Dependent variable was GDP and R square was something like 0.999. Perfectly explained, almost 1. So he said, look, the people were worried so much. I explained it perfectly to perfection. R square maximum value can be 1. He said, now I can tell what will happen in the future, next year. He predicted, and next year came, and the prediction was nowhere close to the actual GDP. Because they felt we believe so much. Our regression is a very good technique. What's going wrong? What happened? Why R square is not able to tell the precise? And they found one very interesting answer. A very interesting thing was, if this is the value of R square, it goes like that. It means you just go on increasing. You simply go on increasing this is the independent variables, and this is the R square. It means you simply go on increasing the independent variable and your R square will improve. Maximum it can be 1. This person has taken the 49. That's why it becomes 0.9999. So it means if I'll say my salary depends on what? So you might tell it might depends on my experience, my knowledge, my hard work, my inputs, right? So far, make something sensible. Then I say my salary depends on number of mosquito in the Kurukshetra. How many planes fly over the Kurukshetra? How many main halls are open in Kurukshetra? Gutter, they are open. Now, this is ridiculous. How my salary will be decided by the number of mosquito in Kurukshetra. But the problem is, if you write any such garbage things, R square will improve. So then they thought of, okay, we must do something else. And they find out something called the adjusted R square. So this is the R square, it will always improve, and that is the adjusted R square. After some level, when it starts going down, it means this is the optimum level. These variables are good, and these variables you are garbage variables. So what is adjusted R square? Adjusted R square is 1 minus R square. It's n minus 1 divided by n minus k minus 1, where the k is the number of independent variables. So we put a formula. And so adjusted R square will always be lesser, or it can be equal, but it is always lesser than the adjusted. And when now number 2, adjusted R square is a comparative indicator. Means what you will speak up from here, the value I have written, nothing much. You should say when 2 variables were there, what was R square? When 3 variables are there, R square will always go up, whether adjusted is going up or not. If it is going up, the 3rd variable you added is really contributing, else it is not contributing. That is what is adjusted. Is that okay?
Okay, thank you, sir.
This story will be sufficient. So adjusted doesn't make much sense when there is one independent variable. Okay, because it has to be, it is basically a comparative indicator. Ask me when there are 2, when there are 3, when there are 4, whether our adjusted is increasing or not increasing. Remember, this was the time of 1949-50. Today we have gone much ahead, and today we have something called the stepwise regression. So we can do with the help of the software that will take care of it. But here comes a really important issue, and the real important issue is what to do in such sort of cases. What to do? Can we go along and make that sort of our regression line? Go to this one, advertisement and sales. We know how to draw a regression. Go to the insert, this much, and draw this. Okay, I got these points and these points. Does it make sense if I'll say draw a line that passes through all of them? Does this make sense?
No, sir.
So how should I go along then? So I have taken these lines. These are the some points. These are the some points, and draw a line. That doesn't make sense. Now we can go to something else. First, to understand the limitation, why I cannot use regression in every circumstance. Because the points are not here and there. In case of the regression, points were something like that. Points were like that. And we were drawing a line. Now all the points available are only in this line. There are only two groups. This is a group, this is the low advertisement here. And this is the group 1 and 0 are the code. They are not really the number, they are simply the code. Now, may I ask Dr. Sanjay to help me?
Yes, sir.
Dr. Sanjay, I have some questions for you, and this is you have to reply on behalf of all the participants. Sir, these are related to the inference. Now, what I will do, sir, since we understand that we can't draw a line, whatever line you draw, that will not pass through all of them. That will just connect maximum 2 points. Am I right, Dr. Sanjay?
Yes, sir.
If we draw a line through this, whatever way you draw the line, that will connect maximum 2 points. So that really doesn't make a sense. So what I will do, I will use another procedure. I will go assume, let's say, Dr. Anjali is t-test. Assume for a moment. Okay, let's so X bar for low is X bar high. Is this true or not? Is this true or not? Now, Anjali ma'am will not speak up much. She will only answer.
No, sir.
So Anjali ma'am will not speak much. I'm repeating. So Dr. Anjali is, assume she is a t-test at the moment. So I will go to Anjali ma'am. I will ask ma'am whether these are same or not. And she will reply only in yes and no. I want you to make an inference if she says yes, they are same. What is your interpretation, sir? I asked Anjali ma'am that Anjali ma'am, I can see here some of the data, like this is the data 42, 50, etc. I will take their average. This is X bar for the low. This is X bar for the high. Are they similar? Are they, there is no significant difference or there is a significant difference? This is what I'm asking. And answer will be only given in terms of yes and no. Sanjay sir, my question is, if
yes,
she says yes, they are same, what will be our inference to this question?
So, sir, inference may be they are closer. Means if both are equal.
They are equal, right? So
then both may be very, very close.
Very, very close, correct?
Yes.
So is my question answered here? Is there any significant relation? Is that answered?
Significant relation, maybe direction. I'm unable to answer, sir.
Not a problem, sir. No, not a problem, sir. Absolutely not a problem. Anyone else? Do you understand what I'm asking?
Yes, sir. If there is no difference, it means that there is no relation. And if there is a difference between high and low, means there is some relationship with the same.
I think somebody else from your house also want to reply. So, Dr. Sanjay, does it make sense what Samir sir said? When he says, let's try to do it, sir, slow by slow. When we say that when the advertisement was low, there was a level of sales. When advertisement was high, there was a level of the sales. When we checked with the hypothesis testing replied, there is no difference. It means whether you go for the low advertisement or you go for the high advertisement, it is really not important. The sales generated will be roughly the same.
So, sir, advertisement doesn't make any sense. It means
yes, 100%. You got it right. You got it right. It means that your product is such which is not impacted by the advertisement. Maybe something like salt. If you show me more advertisement, I won't start eating more salt, isn't it?
Yes, sir. Yes.
So here it says, I think in economics they call it as Griffin good or something like that. So the point here is, yes, sir. So the point here is that if it says, if it, difference and it is null hypothesis, both are same, answer is yes, it means there is, yes means both are the same. Whether you keep low advertisement or you keep high advertisement, you will get almost the same sales. In other words, we are saying it doesn't matter whether you go for the low or high, sales generated it will be the same. In other words, we will say that your advertisement has no role in influencing the sales. Sales is what it is, irrespective of advertisement. So what Samir sir said, a very, very important word. Do you understand here that the word difference indicates the relation? Can you think over it?
Yes, sir, because we can explain with the help of this concept. There is no
Absolutely.
relation,
Right.
because both are, means one variable is not impacting
Right.
other variable.
Absolutely. And what if answer is no, they are not the same? Anjali ma'am could have said that no, they are not the same. In that case, what will happen? Naturally, the next thing will be, then which one is higher?
Yes.
Which one is higher? So X bar
Higher
low
is
seems to
XH.
be around 45. X bar high seems to be around 51 or 52.
Yes.
Okay. So we will say, if you go for the high advertisement, then the sales will be higher. If you go for the low advertisement, then the
Sales will be lower. Right, right.
It
Positive
means
relationships.
positive
Yes.
relation is there. It means we got $1 million thing, sir. A very fantastic thing we got. What is that? The word difference is equal to the relation.
Yes.
So here we are not going for the regression, but inference wise, we can conclude that if the answer is yes, and how Anjali ma'am will say yes or no, she will look at only at the p value. If the p value is greater than this, p value is less than this, then she will say whether the difference is there or not.
Yes.
Okay.
And
so it means,
one more thing, sir.
Yeah,
in the context of inference, generally we see in textbook law of large number they apply. If you increase the variable, it turns towards normality. So is it applicable here also, sir?
No, sir. Not the number of variable, rather the sample size.
Oh, sample size. Sorry, sir. But again, I am sorry, sir. If we increase the sample size, if more than 30, more than 100, more than, let's say.
That will go for normality. That's okay. Yes. Perfectly okay. Not a problem.
Yes, thank you.
Okay. Now
yes.
Here we got a very, very important thing, and let's go to the SPSS. So what was my data? My data was like that. It was given into codes. I have given low 0 code, high 1 code, and 0 and the 1 and the sales figure. I have copied. I have taken to the SPSS here. I have given the code 0 and the 1, low, high, and let me try to run the compare means independent sample t-test. So sales depends on advertisement. The codes are 0 and 1. Continue. Okay. And here check it out. The low, the mean score is 43. High mean score is 58. In my figure, I have written 52, but it was actually 58. Okay. It's a 58, it's 43. The t value comes 2.5. I'm not sure about 2.5 because it's between 2 to 3. Let me go to the significance value. It says 0.037. 0.037 indicates the two mean scores are not the same. Two mean score. This is what I said. Anjali ma'am will speak up like this. So t-test is telling me no, they are not the same. It means whenever we go for the further data, you will always find high advertisement will generate the high sales, low advertisement will generate this one. So Sanjay sir, do you get the answer of the first question?
Yes, sir. Yes, sir. Absolutely.
Can you answer the second question? When advertisement is equal to 50,
yes.
What is sales? Now, technically, the question is wrong because now we have not measured advertisement in numbers. Rather, we have measured it advertisement in terms of high and the low.
Yes, yes, high and low.
Right. And it was more than 33 high. So technically, my question becomes when advertisement is high,
yes,
What will be the sales? Now I will say, see, actually it can be anything between this zone.
Yes.
In the previous data, if I look, when high advertisement is there, I have not seen any case of 100 advertisement, neither I have case sales of 20, 30. It is between 40 to something like 72 or 73.
70, yes.
Right. So I will say it can be between this zone, but I will go along with the mean of 58.
58,
I will
yes,
say
58.
it will be 58. It can be plus minus something.
Yes, yes, plus minus error. Yes.
Right. So I just want all of you to just look at the two cases I have discussed so far. In the first one, we were able to tell precisely the answer. The answer was very, very precise. This was the answer. Okay. And the prediction was very fantastic, 67.22. This time I cannot go with that precision. Still I am able to answer. The first question, is there relation? Yes, there is a relation.
Yes,
and
yes, there is a relation.
There is a relation. If advertisement is high, I will say, well, it will be around 58 plus minus in this zone. Can you see my prediction is diluted, sir?
Prediction is, yes.
In the first case, I was giving it up to in the decimals. So perfect prediction I was giving.
Yes,
but
yes.
Here, prediction is diluted. It will be in the zone.
Right.
Right. Yeah. Any questions by anyone so far, please?
So, sir, in the answer of question B is not, exact figure. It will be
not
in
exact
range.
Figure,
It
rather
will be in
a range.
Yes.
Rather a range. Correct.
Yes.
Correct. Okay. Any questions by anyone, please? I hope people are with me. So, okay.
Yes, sir.
Because
we are wondering how much we will be able to remember after half an hour.
That's a really wonderful. But see, my
you,
point
sir.
was
Thank
just
you.
to let you know, number one, the statistics is not something like a black box or totally something like I couldn't understand. It's very simple. It's very simple. It's very logical also. And it's based on the inference. So one thing which I learned so far, if I am a new beginner, I learned the choice of the statistical tool technique doesn't depend simply on the number of variables, because my research question is still the same. I have not changed the research question. It's still the same research question, that is there any significant difference relation between this and this? So it basically depends on how you measure them. I want you to focus on this particular chart now. When dependent variable is metric, independent is categorical. We don't use regression, rather we use the hypothesis testing. Further, it says, if in the non-metric independent variable, if you have two categories, use the t-test. If there are more than two categories, use the one-way ANOVA. If there are more than two categories, then use the one-way ANOVA. So tomorrow, 5 p.m. session, Professor C.P. Gupta will start with one-way ANOVA. Will you understand what he will talk? So when he will start speaking, you will understand there has to be one dependent variable, which is continuous metric. There will be one independent variable that will be categorical, and necessarily the number of categories in that variable will be more than 2. Because if 2, you can go along with the t-test. However, if with the 2, you apply one-way ANOVA, the results will be same, inference will be same. I'm not saying the value will be same. You know it now, t square is equal to f. So inference will be same. But if categories are 3, you cannot apply the t-test, because t-test works only on the any 2 category. Yes, if 3 are there, you can work on AB, AC, BC, you can work like in the pairs, but you will not be able to take of category. Hope you are not confused between the variable and the category are the separate thing. Variable is something else, and how many options in there, categorical variable, how many categories, like gender, boy and girl. It's a gender is the variable, 2 are the category. However, if I'll say gender, boy, girl, transgender, then it becomes 3 categories, still 1 variable is there. You must be clear between the variable and the choices, categorical choices given in that variable. That's called the category. That's called as the group. Okay. Any questions so far?
Or if we are having a linear relationship, then we are conducting the parametric test, right? Which is regression. Is there any non-parametric test also?
We have the non-parametric test, but nowhere, sir, I said there is a linear relation. I simply asked whether the two mean score, this group got a mean score, this group got a mean score. I simply said whether there is a difference in the mean score or not. I never said the word linear in the t-test or no.
Okay.
The word linear is only for the regression, not in the t-test or no. But yes, there are some non-parametric tests, but here that linear doesn't make a sense. Now, shall we go ahead? Are you with me?
Yes, sir.
Okay. So, okay.
One more thing,
Yeah,
sir. Generally, if n is greater than 30, then we apply other test. If n is less than 30, we apply different test. What are the reasons, sir?
There is no reason, sir. In SPSS, if you look closely, Dr. Bose or something, one participant is making beautiful drawings on my screen. I couldn't understand much from the drawing, but keep on. Sir, if you just look at in the analyze, you will not find any mention of Z test in the SPSS.
Yes.
It's just surprising. So even if you use a t-test on a sample of 500, it will still give you the value of the t. It won't say that, no, it's not applicable. So, sir, it's a simply when the sample is large, then it becomes Z-test. When sample is small, we use the t-test. There is a little distribution difference in their distribution, but there is no other difference. Formula is the same. x1 bar minus x2 bar divided by the standard error. Its formula is the same. So for the large sample, we call it a Z-test. If you have noted, I have shown you the value of t-test. You remember that?
Yes, yes.
In that,
May I ask a question?
just 1 minute. This is the value of the t-test. Here, check it out. Last, it says infinity. T-test can be applied for a sample of 40, 60, 120, and infinity.
And infinity as well.
When it goes a higher value, Z value is always 1.96. There is no Z table, sir. Z value is always 1.96. So we say T becomes Z when it is more than 30. Only that one part is sufficient. Okay, someone else was asking a question.
Sir, you already answered that when T sample is more than 30, then T becomes Z. That's what I was.
Yes, yes.
Did you
But
like
in
the
software,
drawing?
sir, only t-test will be there, and from number of variables we can understand.
Number of variables, what you can understand?
T becomes Z. Means if
Not the number of variables, sir. Categories of a variable.
Okay, sir. Yes.
It's getting confusing. One is a variable. The number of categories of the variable. For each category, how many people are there? There is the three things. One is a
Yes, sir.
sample
How
size.
many people? That number.
That is the sample size. That
Sample
way,
size.
higher the one, it approaches normality. But if the categories are two, it's called a binary question.
Yes.
A binary independent variable, you will use the t-test. Multiple choice categorical independent variable.
We may use ANOVA.
Yes, yes. Variable,
Suppose
option, sample size. These three are the different things.
Yes.
Suppose we are doing a study, sir, of 30 teachers or maybe 30 students, then it has to be, suppose we are taking 2 classes or maybe 2 different schools, then the sample can be like 15 to compare, or it has to be like 30 and 30, 60. Like, how does that work?
That's what is the meaning of independent. Independent means sample size may not be equal. Perfectly okay if there is 20 and the 10. But generally in the statistics, we say it must be comparable. You shouldn't compare 28 with 2. 28 boys and the 2 girls. Can we really go for the generalization on the basis of 2 girls? May not be a good idea. So must be comparable, but there is no such rule that they have to be exactly same. No, comparable.
Like when we come to minimum, like minimum itna sample hona chahiye. So in that case, like suppose 15 and 15 would be okay to compare in t-test.
How much?
15 and 15.
That's perfect.
Okay.
15 is perfect. They are exactly same. but it should not be, actually in none of the book it is given that it is whether I can compare 95 with 5 people. Technically, yes, you can do, the procedure will not deny, but it is not apt.
I'm just trying to ask what could be the then minimum sample, good number of sample then we can consider.
Right. So actually there is no session in this particular workshop on the sample size, but there are 2-3 methods for that one. So you please just write on the YouTube, Neeraj Kaushik sampling design. You will find I have more than 20 videos are there, and 3 methods I have shared. One is there is a formula. One is the thumb rule method, and third is the G power. G power is the software which is used worldwide for sample size determination. 3 methods people write in their papers or in their thesis, and then whatever highest of the 3 they take. One is the sample size formula method. Second is the thumb rule methods. Like you must have heard of, in case of Likert scale, number of statements into 10 is the thumb rule. Okay. In case of regression, it says 50 plus 8K. This is a formula given by Green. It says 50 plus 8K. K is the number of independent variables. 50 plus 8K is the sample of N. If your number of independent variables are 3, it will be 24 plus 50. A minimum sample of 74 should be there. This formula was given by Green. Simply write on the Google, Green formula for regression. So these are some shortcut methods given. And third is the G power. So write it G star power. This is a free, of course, software. You can download and you can work on it. I have explained all this in the Neeraj Kaushik sampling design is the keywords to write on the YouTube.
So I always get clear with the thing that there are certain methods to calculate the sample, but later on I get confused between which test would be appropriate to use.
Okay. So are you getting any clarity now?
Sir,
a bit. A bit.
Okay.
Sir,
not a problem.
Sir, one question here. Sir, when we do the factor analysis, there is something there, sample adequacy. Is that enough for that one, for sample size?
I leave this particular question to Professor Madan Lal, who will take the session on EFA, because sir, I still have a long things to cover. If my session is complete, I'm able to cover all the things, then I will answer your question of EFA. At this moment, I restrain myself.
Okay, thank you.
Okay, so you have seen that I have the same question, and only thing is when the measurement changes. Now let me write it here. There is a DV and there is a IDV, and this is my statistical test or technique. So when this is metric continuous, this is metric, I used which regression. When this is metric, this is non-metric, categorical. Non-metric is the categorical, and only 2 categories are there. I used t-test, but my answer was provided. When it is non-metric and there are the more than 2 category, so I can use the one-way ANOVA. So tomorrow Professor CP Gupta will start with the one-way ANOVA. Now let me go ahead with the third case. Third case is if this is non-metric and this is non-metric, what will happen? If both of them happen to be the non-metric in that scenario, what will happen? So let me go to the Excel file. In the Excel file, and let's come here. So this is the scenario number 3. In the scenario number 3, it happened that people refused to give me the figures of advertisement and the sales. Somehow in the first case, I could get this, but in case it happens, people don't give me the data, then I will say, okay, tell me simply high or the low. So what will be my questionnaire like at the time of data collection? My questionnaire will be like this: advertisement, low, high, tick any one of them, and sales, it's low or high, tick any one of them. So it's something like Samir sir will say high and the high. Somebody else will say this is low, this is high, this way. So I got this data, low, high, low, and so on. I give them the code as the low. Certainly I have decided less than 33 is low in case of advertisement and more than 33 is high. In case of sales, I have taken less than 50 as low and more than 50 as the high. So people have not given me the exact data. I have these categories. I considered, I taken it in the code of this one. So now we know two things for sure. We know regression, we know t-test. Let's try to go for that. Let me make a scatter chart for the same. I got this chart. Okay, can you help me drawing a regression line? Can you help me in drawing a regression line on it? How to draw a regression line on it? Does this make sense? Draw a regression line? I don't think so. What exactly are the dots? So when we go with this low, high, advertisement low, sales high, this is number. Then again, I find somewhere low, high. If it comes again, check it out. High, high, one case, high, high, second case, high, high, third case, 4 case. So how to write? Because it will be dot on the dot. At the maximum, there will be only 4 dots. And then if I start writing, it will be something like, I will write here, these are the 60, these are the 40, these are the 10, and this is 90. Do you understand what these things are? 10, 90, 60, 50. These are the number of the cases. Let me write it as, on the x-axis, this is the advertisement, high and the low. On the y-axis, this is the code, high, 1 is low and 2 is high. 1 is low, 2 is high. On the y-axis, I have the sales. On the x-axis, I have the advertisement. This is advertisement. So what is meant by that? Dots are only 4. Just check this. Only 4 dots are there. And what is this 10, 40, 50, 60? This is nothing but the count. This is nothing but the count. How many cases are there with the low, high, high, high? It's something I have a very small data. If it's a big data, you understand, high, high, 1 case, second case, 3 case, 4 case, 5 case. So I find there are the 60 cases. Low and high, how many cases are there like that? First tell me, do you understand this point, what I'm trying to draw?
Yes, sir. Yes, sir. Yes, sir.
Okay, this is clear. Now, are you equally clear that the regression will not work here?
Yes, sir.
T-test will not work here because they make no sense. Let's find out the average of the two. Because we take average of the variable, 10 and 40 are not the variable, they are the count. They are the count, these are not the variable. Average we take of the sales numbers, these are not the numbers, these are the count. When advertisement was low, sales was high, how many cases were there? So these were the 10 cases. Low, there were the 40 cases. It's something like that. You got it? So neither regression can be applied nor this can be applied. Now what to do? Again, a dead end. So in this case, we will say the good news is in the statistics, there is never a dead end. So we always have some way out. And here we will say the way out is we will go and apply the chi-square test. Chi-square test. So on the PG level, we say this is the observed frequency. Find out the expected frequency. There is something called row total into column total by the grand total. The procedures are given. Then we find value of the chi-square, O minus E whole square divided by E and summation of that. Okay, so I'm not going into that procedure. I'm simply saying it. If what is the null hypothesis? There must be null hypothesis. The null hypothesis is there is no significant association. There is no significant association between variable 1 and variable 2. Right? There is no significant association between the first variable, sales, which is a categorical, and the second one, which is an advertisement, again categorical. Again, we will check if the p-value is greater than 0.05. Null hypothesis accepted, and they will be called as something like equally likely. Equally likely. If p-value is less than 0.05, then it means significant association is there, and it means there is a pattern. There is a pattern. Some patterns are visible. Some patterns are visible. I know I'm little fast, but just try to see it, what I'm saying. Let me try to write a sort of a data point here. I am writing here as this one comes out as 70 and 40. This is 60 and this. If I'll change it little bit as the 80 and this, if you arrange for this particular, now do you know what exactly it means? What is this? If you look it closely, this is nothing but, are you able to identify what this thing is?
Yes, sir. 2 by 2 matrix.
It is a cross tabulation, nothing else. Isn't it? It's a cross tab. When both variables are contained, you are categorical, this is nothing but a classification.
Android Blue Droid, please mute yourself. You are disturbing.
Android Blue, in case you are listening to us, please mute yourself.
Sir, I'm not even able to mute him. I don't know what is the problem. Just let me try. I'll just make him leave the class if it is.
Actually, yeah, I was also trying to mute him, but couldn't. You will have to make him leave the class.
I'll just make him leave the class now.
Please do that, Anju.
Okay. So if in this case, let's try to see if this is the case, most likely your case will be p-value is greater than 0.05. Why I'm saying this? A simple rule in this case is always try to see when one of the diagonal, compare the two diagonals. When one of the diagonal get the sum of the diagonal is equal to the other diagonal. Are you able to understand how much people are there with this diagonal? 160. How many people are there? 140.
Excuse me, sir.
Yes, ma'am.
Sir, we are all now, nobody is co-host. Like there is some change that has happened and you are the only one who is the host. So I just request you to make us the co-host, me and Rekha ma'am, so that we will be able to coordinate the things, sir.
Sure, ma'am, sure.
So I can still operate my speaker and my video.
Ma'am, that is going to be possible, but we cannot change the status. Thank you, sir.
Okay. Thank you, sir.
Thank you so much, sir.
Not a problem, ma'am. I'm just wondering that my session is only for 30 minutes more and you have to bear it for next 2 weeks. All the best.
So we have had a lot of practice now, so it's okay. Thank you so much.
I know. I know. Absolutely. So just look at it. When one of the diagonal is heavy than the other, when one of the diagonal is heavy than the other, you will always find p-value less than 0.05. Let me give you an example. The example is if I make a table like this. So let me make a quick table here. So here I have written sales, which is low, high, and this is the advertisement, low and the high. If these values are, let's say 80, this is 60, this is 20 and the 10. Now compare this diagonal. This diagonal, it is 30 and this diagonal, it comes as 140. When you will find the value, run for this, p-value will always be less than 0.05. My case is not something to tell that you can software will do. My point is when the p-value is less than 0.05, I call it as there is a pattern. There is a pattern. Can you see that pattern? Anybody can see the pattern? The pattern is when the advertisement is low, we can't say sales will be low. There are the cases sales was the high. We can see there are the cases when advertisement is low, but sales is high. But a clear majority you can see, a clear majority is there that it is number of cases are very much when it is low, it is low. And when advertisement is high, more chances are there, then sales is also high. We can't say that when advertisement is high, there cannot be low sales. We have the value of 20, but quite almost 3 times we have the data that it will be high cases. This is what I'm calling as the pattern. Okay, what is the reverse of that? What is the reverse of that? Just see that. If we say this value comes out at 70, this value comes at 90. Now, what is this diagonal? 160. What is this diagonal? 140. Almost equal, and you will find the case of p-value greater than 0.05. It means no pattern.
So in this case, sir, no.
Meaning of the no pattern is they are equally likely. They are equally likely. It means when the advertisement is low, as much cases are there with the low sales, as much cases are with the high sales. When advertisement is high, there are the cases of the low sales, but there are again quite many cases of the high sales. This means we don't know what is going to happen. And this is precisely what we say. When p-value is greater than 0.05, we say there is no association. They are just independent. Anything can happen in the future. Anything can happen. So my point here is this p-value, if it is less than 0.05, it means there is a pattern and we get answer to our question. Sanjay sir, can we find out our answer?
Yes, sir.
So this p-value will certainly tell me, is there a significant relation? It will say yes, there is a significant, or it will say no. If the value is less than 0.05, I want you, it means there is a pattern and so on. I want you to focus on the second question. The pattern is there, not equally likely. So the question here says, if so, it means if there is a relation, what is sales when advertisement is equal to 50? We say wrong one. It's not the 50. Ask me when advertisement is high, what is the sales? My answer will not be a number. My answer will be that when advertisement is high, there are quite high chances that sales will also be high. When advertisement is high, there are quite many chances that, I'm saying quite many chances. I'm not saying that this is very high. I'm saying there is very likely it will be, but there are the cases the sales can be low. Point here is, are you able to look at the three prediction? Case A, I used regression. I gave exact 67.22. I'm just comparing the second point. Case number B, I used the t-test. I simply said, yes, there is a relation and it will be 58 plus minus something. In third case, I use crosstab. In the crosstab, all I am saying is, I don't know. It can be high, but I'm not sure. Maybe 40% cases, 60% cases, it will be high. Can you see my prediction is decreased? My prediction is going down. It's not that quality.
Sir, in third case, prediction is reduced, means it prediction.
It's just a certain, see, actually the point is we say, we don't know.
Yes,
more
yes.
chances are this.
Yes.
Okay, and if I'll explain it one more time, in the first case, allow me to make a somewhat okay sort of diagram, this and this. And check it out, copy, paste, and paste, and paste. These are the three cases I have discussed. In the first case, I had the various dots available like this, and from there, I draw a line from this. This was the first case. In the second case, the points were there in a straight line. So I said, find out their mean, and check whether the two mean score are same or not. In the third case, I got only the 4 dots. It was written something like the 40 and the 60 and the 50 and the 70, something like that. So here I use the B, regression. Here I use the T, and here I use the chi-square. Now I got one more point. If you understood it, I think what I'm trying to tell you, my research question is same. My variables are still the same, only 2 variables, only by changing their measurement. In the first case, I am saying this is metric, independent variable, and this is metric, dependent variable, and I am getting this. I am writing y is equal to a plus bx. In the second case, my independent variable is non-metric, my dependent variable is still metric, I use the t-test. In the third case, my independent variable is non-metric. My dependent variable is non-metric. It becomes sort of a cross tabulation, and I use the chi-square test. I just want you to concentrate and tell me what will happen for an additional sample of 100. If I consider 100 more sample, what will happen? Think over it and you will get a number of insights. In case of additional 100 sample, these additional data will be very much similar to these points. Not possible these values will come here. They will be called as the outlier. If the value is coming here, they will be called outlier, will be removed. So it's something like, if I'll ask Vikram sir.
Yes, sir.
Can you tell me, you belong to which place, sir?
Delhi.
Delhi. What is the average height of a girl, a grown-up girl, 20 plus girl in Delhi, sir? Height of a 20 plus girl.
5 feet 2 inches to 4 inches.
5 foot 2 inches, sir, something like that. So if we have the 100 girls, what will be the average height? It will change to maybe 6 foot, or it will be
5.2. No, 5.2.
5.2, 5.3, something like that.
Yeah.
If we go to 1 lakh girls, what will be the average height?
There can be
slightly
changes.
The point is, sir, somebody, I understand, some girls will be of 6 foot, but then some girl will be of 4 foot also.
Yes, there will be range, upper
so
and
it will
lower.
be the same. So it means all the points may be on the upper side, maybe on the lower side, and if they're too far away, we will call them as outlier and we will remove them. So you will find the larger is the sample, regression results are always very, very stable. There will be changes in the decimal place, very stable. That's what regression is the best one. If we take the t-test and take the 100 each, the data points will be very much, somewhat will be higher the mean, the lower the mean, higher the mean. So can you see the mean in itself is a cushion effect? Sometime it will go up, come down, go up, come down. It will try to get into the same one on the both of the cases. It's the similar sort of things will come. But can you give me the guarantee if I go with both one, will you give me guarantee this will be 25 each? Or it can be 50 people are here, 50 people are here. Anything can be there. So with the cross tabulation, with that both non-metric data, we don't know what is going to be there in the future. So now we come to the last point here with this particular discussion. What the discussion was. Initially, I told you, you may, as a researcher, as a scholar, you may use any word, be happy. But when it comes to statistics, statistics will call, use the word relation here. Relation is a very mature word. Regression got 10 assumptions. Only when all assumptions are okay, then you can report regression. Very, very solid. When it comes to t-test, don't use the word relation. Use the word difference. Number of your assumption reduces from 10 to 3. Only 3 assumptions are there in the t-test. Normality, homogeneity of variance, independence. That's only 3. In case of cross tabulation, don't use the word difference or this. Use the word association. Association is a very, very loose word. Very loose word. Association. Association simply says, from the data it appears that, but there is no guarantee. There is no guarantee. So it means why on the day one I said, you may use any of the word. You just work. Somebody asked a question, what about the impact? Sir, impact doesn't mean anything. Effect, relation, whatever word you write, that's immaterial. What is the important thing? Important thing here is, look at this, the language of statistics. Let's try to learn the language of statistics. Now time to wake up all the participants. If you are not listening so far, now there is something you should listen to. If it was getting too technical, don't worry. Now listen to this. Statistics will always ask you number of variables. How many variables are there? When you have 1 variable, 2 variable, more than 2 variable. This one is called as the univariate analysis. We have the 2 branches here, central tendency, mean, median, mode, and we have the something called the dispersion. There we have the standard deviation, range, minimum, maximum, quartile deviation, this sort of stuff. When variables are two, we call it as bivariate analysis. We call it as bivariate analysis. We have the R, we have the T, we have the B, regression coefficient, we have the F, one-way ANOVA, we have the chi-square. These are the members. When we'll go with more than two, again there will be two cases, that the DV more than 2 or IDV more than 2, right? Here it was simple that DV is equal to 1, IDV is equal to 1. That was very simple. But in case of more than 2, again the question comes whether more than 2 dependent variable or more than 2 independent variable, and the tables will be separate. So this is the first one, and let me show you the tables once again. So again, this is something we should know prior to this workshop. That's why the first my job was to just revise what you should know. When you have the one variable, for example, I think 95 participants are there in this session. I note down everybody's age, only age. What is your actual age? Vikram sir, Samir sir, Anjali ma'am. I note down, including myself. What I can do with that? I can find out one variable, and what is the measurement? Metric measurement. I can apply the mean, median, sigma. Then Rekha ma'am said, it seems there are very serious senior people in the workshop, and she feels average age is 40. I took their mean of all and then compare. I can use the one sample t-test for a claim. Remember, one sample t-test always comes when there is a claim. When somebody claims this is the data set, then you can claim. That's why I said there is no claim that the awareness level was 3. There is no such claim. One sample t-test is basically for a claim. Somebody says something, we check that. Okay. However, if I don't measure the age, I measure the gender. So I find out of the 96 participants, 46 are the men and remaining 50 are the women. What tool technique I can apply? Only one variable, and that's a categorical variable, 2 category. We can call it a binary. I can apply only the percent and the count, nothing else. Only percent and the count. Yesterday, maybe today, somebody asked in the chat box, my objective is to measure the awareness level. Which test I should apply? Do you remember I told you a very important word? The word difference should come for any test to apply. When you said what is the awareness level, answer should be awareness level is such and such. Where comes the t-test? T-test comes into the picture when you say whether the men and women got equal awareness level, whether people of Haryana and Punjab got the equal awareness level. The word difference must come in your objective. You have written to compare the awareness level of Indian and the French people. Yes, the word compare is there. You can apply. When you say to measure the awareness level, where is the word difference? Where from test will come? Do you get it? It's not like you take the data and then you do anything with the data. Not like that. It's first you have an objective, then there are the variables, and then further. So when there is a univariate, we apply this table. When bivariate, we discuss the 3 scenario. When metric, simple regression, dependent metric, independent non-metric, hypothesis testing, both are non-metric, that is called as the cross tabulation. So first question is number of variable. Second is role of the variable. So we discussed yesterday, role is DV, IDV, CV, mediator, moderator. These are the role of the variable. Third thing is their measurement. How you measure them. And that's only 2 sort of measurement we have, either metric or non-metric. Okay. On the basis of it, and here number of variable along with the intention, there must be some intention to check their relation. Whatever word you write, effect, impact, influence, difference, compare, association, leads to, promotes to, yields, whatever you write, anything, be happy with your English. The only point is you need to connect the 2 with whatever word. 2 variables, more variables, intention to connect, you know their role, you know the measurement, refer to the table number 1 if it's a case of one variable, refer to the table number 2 if there are the bivariate, refer to the table number 3 if there are the more than 2 variables. So let me just get to this one and give you an example of each of them and see if you are able to connect. My example is to compare. Simply by the word to compare, you should understand that this is a case of hypothesis testing. Because the moment I say to compare, I will compare something in 2 or more groups, 2 or more categories. To compare the income level of people of state A and B. How many variables are there? Income is the first variable, state is the second variable, which is a categorical having 2 options A and B. Okay, first question, how many variables? 2. Is there any connector which connects the 2? Yes, the connector is the compare. These words are meaningless. To, the, of, and these are meaningless words. So compare is my intention. Compare is my intention. If I'll remove the word compare and write instead of compare to measure the income level. Now what it becomes? It's still 2 variable, but I will measure the income of A, income of B. It's 2 univariate. 2 times I will use the mean score. No t-test, no ANOVA, nothing will come. No regression will come. Why? Because your intention is simply measure. Where is that word? The magic word, the connector. What is the connector? What can be the various? Let's try to write. You can write impact, effect. I try to write these words sometime. Then relation, to find the relation between the this or the difference, leads to, compare, association, yields to, leads to. Whatever words you write or their synonyms, etc. in English language, these I call as the connector word, which connect the 2. These are the connector. These must be there. So measure should not be there. If you write to compare, it becomes a bivariate. If you simply write the measure, these are the 2 univariate, not the bivariate.
Sir, can it be a neutral statement like to study?
Okay. To study is again the univariate, sir. Because whatever the words I have written or their rest of the synonym, they should come. Study simply means, see, Sanjay sir, probably, no, Vikram sir. Vikram sir, just try to think over it. A hypothetical scenario, sir. We are having this workshop offline and we say, let's take a break. You and me come out of the class. Out of the class, I see 1 man and 1 woman. I told you, Vikram sir, they are husband and wife. Am I correct in my interpretation, sir?
Depends.
What depends? My conclusion is they are husband and wife because one is man, other is women. They are husband and wife. Is this correct?
Yes, sir.
The conclusion is that they may be brother and sisters.
They may be brother and sister. They may be mother and son. They can be father, daughter. They can be 2 strangers, not related at all. So Sanjay sir, I simply noted one is man, one is woman. This much I observed. How do I conclude that they are husband and wife? This is wrong, no?
Yes,
Look
sir.
at your statement.
There
When you
should
said, when Hello, everyone. So welcome back. We were at this point. I was saying that Vikram sir, from this particular statement, what I could conclude is simply that from this particular statement, what I can conclude is simply the intention is to report what is the income or the mean level of income of the state A and the mean level of income of the state B. That's it. Nowhere it suggests we will compare. If you have the intention to compare, better to write not the word study, rather the word as to compare, to study the difference. Write those words. We are not politicians that I have written this, but I mean that. No. In academics, you write the proper word. That's my humble request. Vikram sir.
So whenever we find the proceedings research papers published in the proceedings, most of the time, people use this word to study or to analyze. So you mean to say they are wrong?
Not wrong. Statistically, they don't call a bivariate. This is what I'm saying. Now, if you say people write something and do something, then you are free. It's a, there's a democracy, you can do anything. But as per the statistical convention, it's not correct. Writing the word analyze, there must be having some meaning of the critically evaluate, analyze, all these things. I'm just representing statistics. For the statistics, you must write these words, impact, effect, not these words, any other. You check their relation one way or simply writing the words like analyze or the study or evaluate or critically evaluate, it is not an indication that a bivariate analysis will be used. This is my submission.
So my submission is that sometimes, while preparing a synopsis, the students are actually not very much clear about what exactly are they going to do in the next 6 months or after 6 months, or maybe after their, sometime their study might take some other kind of turn. It may become bivariate, multivariate, like that. So they write, some kind of inferences will be drawn, statistical, some suitable statistic. So you mean to say that in synopsis also they cannot be mentioned, such loose terms?
No, sir. It should not be mentioned, and there comes the role of the guide. Yesterday, I told you that at the time of start of the PhD, as well as marriage, we know list about both of them. We just experiment. We have some fancy idea. We know, most of us know nothing. And thanks to the UGC, who says now there is a mandatory coursework for the 6 months. After that, you propose your synopsis. So you are supposed to teach these things in that 6-month coursework. Because people have some funny ideas or the very fancy idea, they don't know what to write. They just have their own interpretation of the things, but that is not correct statistically. Here comes the role of the guide. I'm very, very clear on that.
Right.
Okay, now let's go to we got the last 5 minutes. So allow me to just go for one higher level of it. So what is meant by the higher level? So if I take this particular thing, this bivariate, let me take this bivariate into my whiteboard and see what will happen. I'm taking the case of when the dependent variable is still 1, but independent is more than 1. Then what will happen? If all are metric, all are non-metric or mix, few are metric, few are non-metric, then what will happen? Then in the first one, in case of simple regression, only thing here will be, we will call it as multiple regression. Okay, so please remember, dv is always 1 when idv is equal to 1, and obviously both are the metric and metric. That is called as the simple regression. Yesterday I told you the nomenclature does not depend on the dependent, rather it is on independent. If independent is more than 1 and all of them are metric, the nomenclature is multiple regression. The second case, dependent variable 1, that is metric, and non-metric variable more than 1, all are non-metric. Here instead of hypothesis testing, the concept it will become as n-way ANOVA. The concept of two-way ANOVA, three-way ANOVA, these things will come here. When they are mixed, this will become a case of n-way UNCOVA. N-way UNCOVA. Okay, UNCOVA is analysis of covariance. What is meant by the co? Co is a control variable. Co is a control variable. Here, in case of non-metric, it will be linear. Instead of linear, you can call it as the multiple discriminant analysis. Binary regression will be same. Cross tabulation will be the same. And here, when it is non-metric, it is mixed, we can go for the logistics regression. So these are just the higher versions, which in the coming days, the resource persons will discuss. And I think I have given the same here. This file you already have. When it is like the resource person will come and say, I will discuss logistics regression, what it means? Dependent variable is one, which is categorical, and independent is one. Just check it out, one example. The example, it says, like if I'll say that graduation stream depends on your marks. Now graduation stream is BSc or the BCom, and marks are the actual marks. Here, this is the dependent variable, which is a categorical, and these are the marks, actual marks. Wonderful. So Sanjay sir is not wrong. It's 8 p.m. So his fun time starts. We are actually late. Sanjay sir, we are just concluding. Then you can enjoy with the songs. So the stream is the categorical variable, and the marks are these are the metric variable. So in case we can't apply the linear regression, simple linear regression, rather, since the dependent variable is categorical, we will apply the logistics regression. When the dependent variable is categorical, we apply the another form of regression that is called the logistics regression. Likewise, we can apply linear discriminant also. N-way ANOVA. See what is meant by the n-way ANOVA and ANOVA, and then we will stop. If I'll say sales depends on gender. Sales depends on gender. It means I want to check whether the sales of the boys and the girls are the same or not. And this is a case of the t-test. Further, I say sales depends on gender and the background also. Now, gender means boy and girl, and background means urban and the rural. Now, when I say the combined effect of the two, it means we are checking urban boys, urban girls, rural boys, and the rural girls. Whether the sales generated in the 4 segment are the same or not, this is a case of two-way ANOVA. This is a case of two-way ANOVA. Now, in this case, if we say that sales depends on this, but also on the advertisement, whose effects we need to control. In the sales, first remove the effect of advertisement and then check these effects. This will be called as two-way UNCOVA. So just see ANOVA and UNCOVA, what is the difference? When you want to remove the effect of some control variable, the nomenclature will be UNCOVA. If there is no control variable, it's a ANOVA. So that same I have written here. So N-way ANOVA, all metric, all non-metric. And UNCOVA, it's a mixed one. And there is a concept of control variable whose effect you want to remove. Professor C.P. Gupta will also discuss about the MANOVA. What is MANOVA? MANOVA is the case when the dependent variables are more than one. Dependent variable is more than one. Let me give you an example and then we will stop. The example is sales of the company and the brand equity. Sales and the brand equity together, they depends on the advertisement. If you take one by one, sales depends on this, it's a regression. Brand equity depends on advertisement, that's a regression. But if both of them So first you have to give a reason why both are simultaneously taken. Means both should be very highly correlated. When their R is very high, you take them together, then it's a case of multiple analysis of variance, and this is low and high. It's a categorical variable, but these are two. It's a case of MANOVA. So Professor C.P. Gupta will discuss about it. So friends, I can see this will be a fantastic 2-week workshop because all the resource persons are just amazing. Professor C.P. Gupta, Professor Madan Lal, other faculty members from Delhi University, Professor Dangi. These are, most sought after resource person, and few of them are my teachers. I learned everything from Professor C.P. Gupta. So I hope you will have an excellent session, and always remember that I'm always available on emails. Whenever anybody feels that you want to discuss anything I can help you. So my mail ID, I'm writing in the chat box. It's kaushikneeraj@gmail.com. KAUSHIKNEERAJ, kaushikneeraj@gmail.com. You can reach me on Gmail anytime. I'm never available on phone. So only on the mails I'm comfortable, not on the WhatsApp or something. Email is okay. So I once again thank the organizers for giving me this opportunity. Back to you, Anjali ma'am.
Any questions, participants? I think you have an excellent opportunity to ask Professor Neeraj Kaushik, because we are indeed extremely grateful to him and honored to have him with us. I know the kind of busy schedule that he keeps. It must have been very difficult to take out even these 4 sessions with us. But I am sure that each one of you is benefited listening to him. He's so lucid and so clear that it's a treat to listen to you, Professor Kaushik. Any questions that you have, it will be, I think, nice to ask sir right now so that your queries could be resolved.
If possible, just if you can, fit him into some session of half an hour wherein it will be a dialogue. I mean, it is a dialogue. We can ask only the questions because we'll be reading some, material on this, and then I think it will be better to ask him some robust questions rather than, some silly questions.
We will keep this in mind, and we will see if Professor Kaushik is free sometime. Definitely, we would request him to come back to us for at least an interactive session where you could ask your questions only, and he could answer them. If that's, we would try our level best to do it.
Ma'am, Tuesday is a holiday for me. So if you are comfortable from 3:30 to 4:30 or 4 to 5, I'm okay with it.
Perfectly fine, sir.
Sir, ma'am, good evening, madam. Any handouts, madam, whatever Kaushik sir delivered, like share a soft copy?
Sirs, this is going to be on the YouTube, so you can.
I will share the relevant playlist, ma'am.
Sir will share the relevant playlist.
Thank you,
And
ma'am.
sir, 4 to 5, sir, we'll just fix up and come back to you, sir. Tomorrow we will confirm it with you. That will be lovely to have.
Definitely. Tuesday 4 to 5.
Yes, sir, 4 to 5 Tuesday. I've written down, and I will just work it with the technical team and inform all the participants on your Telegram group. So please be vigilant, because Tuesday you could have a longer session instead of 5 to 8. You could have it from 4 to 5 with Professor Neeraj Kaushik, and then 5 to 8 with the other people.
Ma'am, we'll be delighted to have such a session.
Thank you, sir. Thank you so much, Professor Neeraj Kaushik. I don't have words. Words fail me to thank you, because it is extremely gratifying to listen to you and to have you with the participants. I know the kind of legacy that you are leaving behind. There is so much for them to learn. And I think on Tuesday, they'll still be able to grasp some more. Thank you once again for being with us.
Rekha ma'am,
Thank
hello.
you.
Hello, Rekha ma'am.
Yeah, yes.
Yes, sir. Would you please allow me to talk for a few seconds only?
Yeah, sure.
Neeraj,
please go ahead.
Yeah, sir, a very good evening. Sir, I used to visit your YouTube channel very frequently, and there is some there are some mixtures in the playlist. I hope you would agree. So on Tuesday I would clarify that in which playlist I can find this content. Sometimes it is overlapping, sir. That's why I hope you would agree. Thank you, sir. Thank you so much, Rekha ma'am and Neeraj Kaushik, sir.
Thank you. Thank you so much. Thank you, sir.
Just 1 minute, ma'am. Actually, he got a very right point. The number of videos are more than 900. At times, even I'm not able to find my own videos on the channel. So I have prepared a playlist, like it shows you only the details of the which playlist contain which video. I have shared in the chat box. So this particular is the page from the Google Drive where I have given in the systematic that this is the playlist of SAM. This is for Smart PLS 2, Smart PLS 3, RStudio. This is separately. I think it's more than perhaps 51 playlists are there. I know it's very confusing. So maybe this particular video, the link can help you. I will put it into the
I'm
chat.
having that one, sir. I'm having in the first FDP. I
Then-
was there.
then ask it
This
on
is
Tuesday
2.0. This is 2.0. So I was in that at that time. You had said still, sir. Still there are some
Okay,
overlapping.
let's meet on Tuesday.
Okay, thank you, sir. Thank you.
Okay,
Thank you so
ma'am.
much.
Good
Thank
night,
you, sir.
everyone.
Good night,
Bye.
everybody. Good night, sir.